So that doesn't work. Like we have chosen a much safer option. So which is nothing but we used a pattern which is triangular fit pattern, where this pattern is nothing but, like, it's simple but powerful, where we build our new systems around the old systems and we try to replace it one by one instead of completely removing everything, like until we say the old system is completely covered and can be safely retired. And to do this, like, we have 3 core principles. One is parallel runs. So that means this is nothing but, like, we have the new system and the old system. So we try to compare these 2 systems and check for the results, and that was our guarantee of accuracy. So through which, like, we can say we successfully modernized a particular component or particular module. So now the second one is incremental replacement. So we didn't replace the entire COBOL module at once. We did it module by module instead of tackling everything at once. And next, the rollback first mindset. So it's a final point, but it's very important to have a plan B for any deployment. So if anything went wrong, we can go back to the legacy system, so that way the business won't get disrupted. So this is the high-level architecture, where you can see the gateway is a main component here, where it is built using the Azure API management. And think of it as a traffic cop, where any request coming in, like any client request or any request coming in, the API gateway is something that will decide where it should go. It should go to a new microservice or new services that we built, or it should go to the legacy systems or the legacy COBOL APIs. So like we built the new microservices in the which we hosted on the Azure Service Fabric, which was our reliable orchestrator, and we used the CQRS patterns as well, so which we'll discuss further in the coming slides. So I just want to mention here from this slide, the takeaway is the API gateway, so where it's our main component. And to build our new system, we used it like a powerful but cohesive tech stack. So for application layer, we went all in on the latest from the Microsoft, like .NET, C# and MediaTR for CQRS implementation. And for infrastructure, we used the Azure Service Fabric. So this is something like which was our orchestrator, which works as our orchestrator. And also the service bus, the Azure Service Bus, this was our messaging backbone. And Azure Functions for handling any serverless workloads and all. For DevOps, like our process was automated using the Azure DevOps pipeline. And for infrastructure as code and legacy, like we use the Azure Bicep templates. This is to define our cloud environment. Like it is very readable, and we can know what we are trying to deploy, and it is defined very clearly. And next, the clever combination of the PowerShell scripts and the source generators. So this came into picture, like when we have this example of having a COBOL mainframe code, and we wanted to, like it has decades of business logic, as I mentioned before. So we wanted to completely pick all the business logic, so which some of the developers even touch those for like over the years. So it just was there existing. So we wanted to extract that logic as well. So these two combination came into picture for the COBOL code translation. And now, one of the coolest parts is the again the COBOL to C# translation. So here, like when we have these much of business logics which is existing for 30 years and which we haven't touched some of the parts. So now, how do we make sure like we safely translate all the business logic from COBOL, like which some might have understanding to that and some may not have the understanding to that business logic. So yes, you automate it. So we automated the extraction of the business logic using the PowerShell scripts. So these PowerShell scripts helps in extracting the business rules, whatever is present in the COBOL, and then it is fed to the source generators. So the source generators, which has which converts into the C# classes, clean C# classes, so which acts as a C# translator. And using that, like as shown in the snippet here, the COBOL code before, how it was, and after when we use the combination of the PowerShell and source generators, so this is how it has been converted into the C# classes, which we'll be using in the, which this will be used in our later conversions, later movement. So now for the API management layer, this is one of the, like I would say, heart of our migration strategy, where this API management, we have built this using the Azure API management to get the unified gateway. So this is not just a simple router, but it acts as a like a traffic controller, intelligent traffic controller. Like for example, when clients sending any requests, so as I said, the API gateway decides where it should send. It should send to the our newly built shiny microservices, or whether it should send to the legacy COBOL APIs. So this part is something that decides where it should go, and I'll go further and tell how we have achieved this. So for this, we also have to enable the gradual traffic shift from the from the legacy COBOL to the new microservices. So that was done via API versioning. So API versioning, how it comes into handy is, for example, like I can say an example of modernizing the policy lookup, where we expose it as a version 2 endpoint, and now the version 1 is still on the still pointing to the legacy COBOL APIs. So now we could tell our systems to point to the version 2 and get the response, and we will also so this is like if anything went wrong, or if there is any change, if anything went wrong, we can immediately switch back to the version 1, which is still on the legacy systems. That way we won't disrupt the business. So this way we try to migrate each piece, all the modules one by one, like doing the versioning, and then also keeping the old version and comparing both of them as well. So this layer in general gave us the control and complete control, and also monitoring, like to have the comparison and to have the guarantee checks. And the other critical part is parallel validation architecture. So like our commitment to, so this was nothing but a critical key part, like where it was our commitment to trust but also verify. So we never assumed that our code would just work, or it was always right. So what we have done is we have built an automated parallel validation architecture. So it is so this can be done through like a couple of steps. So one is dual processing. So the dual processing is enabled only for critical transactions, and also like so which is nothing but like we were comparing the we have a new system, we have an old system, and we are comparing both the results from the old system. In the sense, API gateway, when we have any request coming in, so the request will be sent to the we have an existing system, and the request will be sent to the legacy system. Now we'll get the official the response from the legacy system, and we will also send the shadow request of that shadow copy of that request to the new microservice as well. And that's how we'll compare both the results, and we will see if how much accuracy that we have and all. So in general, our new service, any new service that has been modernized or re-architected, so we will make sure that service goes through like thousands of real world scenarios like this, and then only we make sure we check for the accuracy, the utmost accuracy, then only we will roll it out to the business users based upon the stability. So this not only gave the confidence to the business users, but also ensured the data integrity. So this way the comparison was the key for guarantee. And also with this, we were able to migrate it smoothly. And here, workflow orchestration. So the insurance processes, they are not simple all the time. Like we have different multiple workflows over here. For example, claim that needs to be approved. It needs to go through different steps. So one is submission, to validation, to approval, to payout. So all these steps needs to be executed or needs to be completed successfully. So the challenge here is who can ensure all these steps executed successfully is something. Then here comes the powerful pattern, which is distributed saga. So distributed saga pattern, so the responsibility is to make sure everything executed in an order. If anything fails, it will try to trigger the compensation logic. So it will send a command to the services and say undo your work. So this way it is helpful for all the steps to be executed in the order. And also, like all the independent services that will handle all these steps, so we have to tie them together. So that is where we have the event-driven messaging, where they communicate asynchronously. So this is the workflow that, that has been, for one of the example of claim. And yeah, one of the critical part again here is communication here. So now the old system and the new system both speak different languages. So the old system understands the like the legacy system understands the older message formats, and it expects the data in a certain fixed width structure. So now, and also the new system understands JSON. So now now we have a challenge that both the systems don't speak same language. So now for this we built a middleware. So this middleware is like why, how, and like what is middleware? So what is middleware? It's nothing but a bunch of services whose main job is just to translate. And when it comes into use is when we have a functionality when a new system wanted to speak to the old system, like a new system which has been modernized but still has some data or still needs some function to be called from the old system. So this communication that we need to handle it carefully. So then the middleware, so whenever any new system sends a request or wanted to speak to the old system, it will send a JSON request and it will send it to the middleware. So then middleware, it acts as a universal translator, and it will translate, or it will convert that the JSON request into the COBOL understandable fixed width structure. So and
so I have one question regarding this middleware. So is it time consuming because you are introducing new middleware to convert like JSON or to the certain features or coding understanded by COBOL, right? So do you find it time consuming because you might have lots of requests coming in or coming out?
yeah, it is time consuming and it is complex as well. But like now I'm saying about a system that was like 30 years old, where no one has an idea, like because people come in and go out, so no one has any standard approach or standard idea of what the business logic is. So in order to get that business logic out from the which was living in the COBOL, the only approach is to automate and also use this middleware to translate. When we are using the new services, so and definitely the COBOL services speak the old languages or understands the old language. So now we definitely need a middleware when we have this kind of legacy system or legacy architecture. So this is expected, and we already knew that this would be a long process. So that's why we kept the new system and the old system parallelly, so that we didn't want to interrupt the business as well, but wanted to recheck every time with any new service getting re-architected.
So in certain version is deprecated of COBOL, and you have APIs, legacy APIs in COBOL. So how are you going to handle that? Like, are you going to build this API in C# again, or you want to go with a new version?
So here in this, we all dealt with already existing COBOL APIs. Now we wanted to move. So that's where versioning is something we still kept the versioning up, because we wanted to, as I said, we wanted to do it module by module. So when we are doing any change for or re-architecting a model of policy lookup now, and then when we are exposing it as version 2, the system when the requests come in, we'll say, hey, use this version 2 as we have re-architected it. But and don't use a version 1, but we already tested it on the behind. This was nothing to the user, nothing known to the user, but we have already tested in the behind, where we have run through different scenarios of version 1, how the response would be, and we have run the shadow copy, I was saying before, where we have the same copy, we'll send it to the new service as well. So then we'll compare the outputs over here, through an automated process, and if there is any difference in the outputs, then we will get an alert and we will investigate and we'll try to change the versioning API. So this way, when we only make sure that the current version is good, then only we deprecate the older version. So till then, we are still dependent on version 2 and version 1. So we still don't depreciate it immediately.
So when you're parallel running all the new services, for new services that require write access, are they writing to a shadow copy of the production database as well?
So yeah, that will come in the next. So we have a database setup, so where we have different, we have separated couple of requests. So the database is one in the same, like we haven't changed anything on that part. So we didn't, don't want to do any different approach because we are dealing with the data, live data. But it will just through the endpoint, like as we are exposing it as a different endpoint, but the like I would say, the talking is different, but the way of how they reach the DB is something that we have changed in this translation. Got it? Okay. So, okay, let me complete this. Yeah, so like we have this middleware, like where we try to, like when, as I said, when we want to talk in the old system or new system still wants to talk, this middleware will translate the from COBOL understandable language to JSON understandable language. So this way, this allowed us the migration incrementally possible, like without any disruption. And yeah, one of the example that we re-architected that I can share is claims processing, where this claims processing, for this we used the CQRS, so which is nothing but the command query responsibility segregation, where we have like think of it as any busy restaurant that we have, like and we have like a line waiting, people waiting in the line for ordering, get stuck behind the people who are ready for their pickup. So now then what we will do, we'll just create two separate windows, one for ordering the food and one for picking up. So similarly, we have done the same thing with the data. So this is just like how to make the like user experience better. So we did the same thing with the data. So whenever a request comes in to change the data, so we try to like think of it as a command, like we call it as a command. Then it will go through the ordering window path. So this path is all about safety and validation rules and business rules, following the business rules, which is defined in the domain-driven model. And then once it passes that, it will save into the right optimized database. And let's say a request comes in to read the data. So now we call it as a query. So now this reading the query will go through a different database, and which is specifically for optimizing for its speed. So this way we separated the write and the read tasks. So the main aim for this is to, like we have to achieve that performance and also the user experience. Like we made sure that the read, anything that is related to reading data is fast and never slows down the new claim processing. So this way we separated it. And yeah, so this also like got us like a couple of like we were able to migrate it with this easily, and we re-architected the claim processing. So now for the pipeline, like we used the Azure Bicep templates to manage and build the cloud environments. So as shown in the snippet, so this is readable, and it speaks for itself, like what is defined to be deployed, and it has like different kind of, like we have used the networking and storage resources as well. So these are all we leveraged heavily on the Azure when coming to maintaining the cloud environments. And yeah, all of the practices that I mentioned, it will come together into the CI/CD and deployment pipeline, where from taking the code from the developer's environment to production safely. So it goes, so the source code, like as you see, it goes through a couple of steps. It will be automatically built, and it will go through the tests, automated tests. So these tests acts as a quality gates, where if it doesn't pass, then the release stops. And we use the advanced deployment, which is canary and blue-green strategy to minimize the risk. So it is nothing but like when we are trying to modernize or when we are trying to use the new services, so we wanted to see if it's stable, and then only then we'll send it to the subset of users, and if it is stable, then only we'll roll it out to everyone else. So, and also the entire process that we have done with a safety first mindset. So we have to have we had a rollback capabilities every time in every single deployment. So if immediately if anything goes wrong, like we have a chance to go back to the legacy system. So now what are the results of all this work that we have done? So the outcomes are transformative here, like we are able to get the policy issuance time down to 4 hours from 5 days, which was very long. And we were able to migrate, the entire migration was accomplished with zero disruption, like with zero downtime, and like while maintaining the business, eliminating also the business risks. And we were able to meet the uptime requirements as well. And yeah, the business impact is also huge. Like now we have a system like which can scale horizontally, and which is also like resilient and improve the customer satisfaction at the end. So yeah, the final closing. To close, like I want to share a couple of lessons that we learned. So one is incremental modernization beats big bang rewrites. So the strangler fig pattern is a key which allowed us to manage risk while delivering the business values. Like we don't have to do a complete migration at once when we have any critical applications or any legacy applications. So we can just go piece by piece, take your time because the business is still running. So at the end we don't want the business to end. So we have to do it incrementally. And also the parallel validation. So yeah, as I said, we ran both the systems at the same time with the same data. So and we matched the outputs and we checked for the accuracy. Then only, like that was a guarantee for our accuracy. Then only we rolled it out to everyone else. And yeah, the rollback capabilities. Yeah, you have to have a plan B for every single deployment. Like if anything falls back, like we have an option or we have a safety switch. And blending the modern practices. Yes, combining all the tech stack that I mentioned, so whichever fits the team and also whichever fits the issue, the legacy, the type of legacy system that we have is something that we have used, and that created a system that is maintainable and resilient and can be scalable. So yeah, thank you all for listening this, and thank you.
All right, we'll go ahead and get started. We only have 25 minutes. We're going to jump right in. I apologize a bit because this talk is at least a 50-minute talk. So batten down the hatches. We're going to move quickly. But I've got on every slide, let's just start the first slide. You'll see a QR code. That's to download the slides. You can also go to the website for this conference and download the slides there. Either way, you'll see it on every slide, so don't worry about I'll have a bigger one at the end too. So what we're going to do is talk about modernizing your .NET skills. How many here are .NET developers? Sweet. Okay, you're in the right room. Cool. So my name is Tim Corey. I teach software development as a job, which is awesome. And a lot of what I do is .NET. So we're going to talk about, there's a lot's been changed since, .NET 6, .NET 7, .NET 8, .NET 9. Guess what's coming in November? .NET 10. So along with Visual Studio 2026 and a whole bunch of other changes. So we're going to get right into what we should be thinking about. And there's some big things and little things, and these are just the tip of the iceberg of all the things that are going to be in here. So let's start number one. I don't know if you've seen this yet or not, but SLNX files. We've all seen solution files. SLNX files are kind of awesome. What Microsoft did is they looked at that SLN file, which is a big, confusing mass of XML, and they went, why do we have to have all this stuff? And even worse, when you have a large project and you're trying to synchronize changes and you have a merge conflict on the solution file, you have a mess because you don't know what to do with that. Well, this is an entire SLNX file for 3 projects, I believe, in one solution. That's it. That's all it is. Good luck trying to even do a file new project and seeing something that short in SLN. They're huge. So this, really easy to read, solution, project, 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 and there's a path. Done. This also allows for a lot of other things in there, but what it does, it takes all the defaults and says, let's just make them defaults, instead of specifying what the default is. You can obviously add more things back into this, make it more complicated, but by default, these are pretty awesome. You can upgrade your solution file to SLNX just by saying file save solution as an SLNX. Number 2, this may have terrified some people. If you do APIs, they remove Swagger. Oh no! Good news is, with one line of code, you can bring Swagger back if you really miss it. What they did was, Microsoft has this weird problem, especially in the community, in that people think if it comes from Microsoft, it must be the only way of doing things. It's the right way, it's the gold standard. But we need to have more flexibility than that. And Microsoft said, hey, what we can do is support the open API specification and allow you to make the choice of how you want to then implement a UI for that if you want to. And so we have 4 options. They're great out of the box. Kind of out of the box. They're third-party packages. Excuse me. Swagger's still there. We also have NSwag, Redoc, and Scalar. So feel free to pick one of those or build your own or look at another third party that's being built. But there's some great options out there. I do have links in some slides, not all of them, but in some slides to a more info. If you want more in depth, I've got like an hour talk on YouTube just on this topic, showing you how to use all 4 of those and talking more about it. Obviously, we're not going to get into that in 1 minute. All right, number 3, Aspire. Who uses Aspire? Okay. Who should use Aspire? Everybody raise their hands. Yes, Aspire is awesome. So Aspire is, people are confused as to what Aspire is, so let's talk a bit about that. Aspire is for local development. People ask, well, how can I deploy this to the server? That's not how that works. It's for local development. People ask, well, how can I use this to deploy my services and systems? That's not the original intent of Aspire, although they are starting to work into making that part of the process as well. The whole goal of Aspire is to make our jobs as developers easier. Now, our jobs as developers tend to be all over the place, from building the code to deploying the code to maintaining the servers, which is why we start asking these not dumb questions, but questions that are outside the scope of what Aspire was meant to do. What Aspire does is, and I was going to put a screenshot here, it wasn't quite representing it. Essentially, in a few lines of code, it says, here's what your application looks like. Let's wire all these bits together. So your API and your database and your whatever else, Redis, whatever you're bringing in, whether it's Docker packages, whatever else, it does all of that in .NET code, which you can then check into your repository. And so then the rest of your team, when they download that code from the repository, they can spin that up very quickly. But not only that, when you just hit File Run, you get a project dashboard that lists every single different launchable application you have. So if you have an API and you have a front end, it's going to list both of those with their ports. You can launch it right from there. But then it also has all the console statements from all those different projects you're running. Plus it has a structured log viewer for all those different projects. You can investigate what's going on. It also has all your traces in one spot. And it also has all your metrics for your application. This is out of the box, a few lines of code. Check out Aspire. They're going even further down the road with things like deploying to Azure. And it really is platform agnostic. You don't have to be just Aspire. You don't have to be just C# applications. You can do a lot more with Aspire than just that. So don't get caught up in the idea that Microsoft created it, therefore it must be only for Microsoft stuff. So that is Aspire. Number 4, minimal APIs. I love these things. I have built APIs for decades now, and I have gone to almost entirely minimal API for everything I do. And the reason why is because Microsoft realized, and we're going to see this in the next few slides, Microsoft realized that they had a problem. And what that problem was, they started looking at what does it take to get started with .NET. And they started to realize that a file new project involved hundreds of lines of code. And it had all these different moving parts that, once you're a .NET developer for 5, 10 years, you're like, oh yeah, I don't understand every one of those parts. But what does it mean for a new developer? It means you have to learn hundreds of parts, and that's a huge hurdle to get into .NET. And that's one of the things they realized was a stopping point from new developers using .NET. Minimal APIs, they realized, hey, we got all this ceremony around an API. We have, the constructor itself. We have all those naming conventions. We have all this, implicit stuff and explicit stuff. We have decorators and all the rest of the stuff. When really, this right here is an entire API. Everything. That's an entire working application. Now, the one thing I did do is say dev.print messages. It's calling out to your library or whatever else you want to do, but that's an entire API. That's from declaration to wiring it up to HTTPS redirection to actually mapping a GET command. All of that in one little section. So what does this mean for developers? It means easier to maintain. It means you can group things in a different way than just, it has to be in the home controller as part of the home routing path. Well, no, you don't have to do that. You can make a smaller system that's just these things that are logical to whatever it is. So minimal APIs, check them out. They're full featured. They can do everything that controllers can do. I think there's no more limitations. There was a couple limitations were tiny little edge cases that have been eliminated in .NET 9. .NET 10's even improving minimal APIs. All right, who loves file scope namespaces? Sweet. Yes, I love these things. Essentially, all they do is save you whatever spaces that is, 4 spaces by default of horizontal space. And I have people fight me over this. Like they really want to have their old namespace style, the scoped namespaces, which is fine. You can still do that. And that's one of the things that is wonderful about the new way Microsoft is developing, and that is they're not breaking stuff. Like if you have your old stuff, cool, use your old stuff, use it the old way. But one of the things they found was, again, we look at all the complexities of what .NET does and how complex a startup project is, and they realized we're only putting one namespace per file in, 99% of the cases? So why not just put a semicolon at the end instead of having curly braces that surround the entire scope? So if you use the file scope namespaces, you save 4 spaces horizontally for your entire application. And if you need 2 namespaces for one file, you're doing it wrong. I mean, if you need 2 namespaces for one file, then just use the original way of doing things, okay? So, but again, maybe rethink your process if you have to have 2 namespaces per file. There are exceptions to the rule, but that's a very small exception pool. All right, number 6, top-level statements. So this is an entire console application. You've probably seen file new project for a console application. Again, Microsoft had this idea that we've got too much ceremony. So even in a file new project for a console application, which was a simple little project, we had a namespace, we had a class, we had a program, or we had a method name, we had the parameters for that method. We had all this stuff that you had to kind of swim through in order to get to the right spot to put your hello world to get started. Now, that benefits the very new developer because we're not showing them all the stuff they're not using it anyway. But it goes beyond that because of the fact that it makes all of our applications have less lines of code, which means there's less to review when something goes wrong. So I have a whole rant on this if you want to go watch that YouTube video, because one of the things that I talk about is the fact that people push back over this. They're like, oh, we're hiding stuff. And technically, yes, they're hiding one thing, and that is the parameter that comes into the args parameter that comes into the main method. However, we have a method, and people fight for, we need to see that method, but that method can't be called. And we have a class that we really shouldn't be calling or using, and we have a namespace, which, if you want that namespace, you bring the using statement back in. So why do we have all this stuff we can't use because it's not the same as a normal one? It's not a normal class, it's not a normal method, therefore why are we treating it like it's normal, even though it's not? So therefore, I would encourage you to start moving that direction. Again though, Microsoft is not breaking compatibility. You can have your .NET 3.1, Core 3.1 application, you upgrade it to .NET 9, .NET 10, it will still work with the whole structure. You can even say, don't use top-level statements. It's a confusing, unchecked checkbox, but if you do, you can still get the class, the namespace, and the method name. So top-level statements. This is a newer one, and this I almost jumped up and down physically for joy with. How many of you have ever tried to instantiate and put an initial value into an array? And how many of you go, wait, what's that syntax again? Is it new square brackets, then quotes, then curly braces? And again, why? And so what Microsoft said was, hey, well, if we just use square brackets for everything and call that good. So when you instantiate a list of string, you can use square brackets. If you instantiate an array of string, you can use square brackets. If you have a collection, you can use square brackets. Whatever it is. Now, this is actually a really complex piece of architecture they did, because behind the scenes, what that is doing is using the most efficient way possible to instantiate that specific type. So if it's an array, it's going to be different than a list. And so they're actually doing some translation behind the scenes that we don't have to care about, because we're using .NET. And .NET lifts us up out of the muck of all the twiddly configuration stuff and lets us just say square brackets go. Now, along with this, I wanted to throw in a kind of a bonus one here. This also works with the spread operator, which is another one that I don't use that often. When I do, I'm like, oh yeah, that's great. 2 dots. So you do 2 dots and a name, 2 dots and more names, and that's going to combine those two arrays or 2 lists into a new string array. And again, notice we've got 2 lists of string going into a string array. So we can chuck things all over using our arrays, and it just works. Again, it's making our lives a whole lot easier. So, collection expressions. That's number 7. Number 8, random methods. So, random used to be more difficult to get right because it's not thread safe by default unless you instantiate it properly and make sure you're doing all this stuff. Now we have just random.shared, which is thread safe. You can just use it. There's no need to instantiate a random. You just go ahead and say random.shared, and you're good. But there are 2 new things they've added in random in .NET 9, and that is, number 1, get items. So notice there, I'm not getting into all the code, but combo is a list of items, and I'm saying just give me 2 random items out of that list. So, and you can, whatever number you want, just grab that number. So that gives you a subset of your items randomly. And again, random.shared.shuffle. So for all you, those of you who are creating card games for demos, shuffle. There you go. So, random. All right, that's my random update to my. Okay, Thank you. That one pity laugh. All right, number 9, alias any type. So aliases have gone a little out there. We always have had using directives. So using system.net and demo API. These are normal. But then in .NET, I believe it was 6 maybe, we add the ability to add a using static. So we have a lot of console.writeline, console.readlines in a console application. We could say using static system.console, and now we can just put in our code write line and read line because we have that using static. But then we added the ability to use alias any type. So for example, please don't do this, okay? This is one of those, so you can do it, don't do it. But what you can do is, we've got a tuple. We could name that tuple. We call it person. Now we can use that tuple as if it's a named item. Okay, that's not the greatest of examples. It's an example that shows that it works, okay? I have found this is an edgier case that you might not want to use that often, but it's possible. The other thing is you need to know it's there because if you see it, you're going to go, what's going on here? Especially when you see something like read line or write line in code. Why is that working? Because of the using static. Well, the same thing down here. You can alias any type you want. So you could alias a string and call it a double, I guess, doubles. You know, it really messes with people's code. But alias any type is there. All right, primary constructors. Here's what I go back and forth on. You've probably heard a lot about it. You've probably seen a lot of people talk about it. I don't know, how many of you have used primary constructors? Okay. How many love them? Okay, I got a couple. All right. I'm on the fence on primary constructors because of the fact that I don't think they're fully baked yet. Okay. They're getting there. Maybe .NET 10, I haven't seen yet the changes I want to see in primary constructors, but maybe. So what we got with primary constructors, the idea is that if you're using dependency injection, and let's say you're injecting, I don't know, your iConfiguration, and that's all you're doing at your primary constructor. So you have a constructor that says iConfiguration config, and then you assign it to a variable that you put into your class, you then access in the rest of your class. Well, with primary constructors, we can say, you know what, let's just put it at the top here, right next to your class declaration, no need to declare a constructor. The problem with this is what it does, it makes this variable, first name and last name, available then for the rest of your class as a private variable. But it's mutable. Don't love that. So you can still make it read-only, and you can change the name like this, private read-only string underscore first name equals first name. Okay, that kind of works. Or you can force them to be read-only by assigning that same name to itself. So if you say private read-only string first name equals first name, then now first name is read-only, okay? And you can actually still use a regular constructor and bring that in using the this command, so you can bring in the primary constructor into a regular constructor. So you can do all the same stuff, but at this point, maybe we just use the original constructor and call it good. So there's a limited use case. I think that what's going to happen eventually, I'm not sure if it's going to happen in 10 or not, is I think there will be some type of decorator here for make this read-only. I think that would solve 95% of all my concerns with it or quibbles with it. Because I don't want my items I'm passing in my iConfiguration to be modifiable. Okay, so I want it to be read-only. So that's the only thing that I think that would be needs to be upgraded with that, but primary constructors do exist. There is a reason for it. What Microsoft is doing is looking at all their code again and saying, why do we have all this boilerplate? Why do we have these ceremonies? Why do we have all this stuff when really we don't need to? Because that tells you exactly what's happening. We're bringing in first name and last name. It's just how you bring it in that's then the question. So that is primary constructors. Number 11, keyed services. So use dependency injection. And you have two different dependencies that you want to bring in that use the same interface. Well, you can actually name them. So I've named this first one, the MySQL one, MySQL. I named the second one, SQL. And then when I can ask for it, by the way, this is a minimal API, but I can ask for it by saying from keyed services and ask for it by name. So you can do that if you want. You can still then ask for just the iSQL and get the array of them, or the first one back, whichever you ask for. But keyed services allows you to actually name them and get a specific one back. Okay? And again, there's a video with more information about that. All right, Blazor web apps. How many of you use Blazor? Okay. How many of you are web developers? All right, a few more. Then use Blazor. Okay, check it out. So Blazor, I'm going to give you a brief history of Blazor. Blazor came out from an idea that Steve Sanderson had, where he's like, what if we could just do this crazy thing? And he actually created Blazor WebAssembly. But then they released Blazor Server first, because it was more baked at the time of launch in .NET 6, I believe. So Blazor Server, the idea is that we use SignalR to connect between the back end and the front end. So it's an open connection for every client as long as they're connected to the server. But what happens is we get all of the rich UI ability of a client-side application, but it runs fully on the server. The benefits there are we can have things like connection strings and talk to the database directly and all this other stuff on the server secured, but yet still have the ability to have pages that change without a full page refresh. That was Blazor Server. The downside is you've got that constant open connection with SignalR, which means that if you have a glitch with your internet, all of a sudden it gives the dread, we need to reconnect you, and then it loses session potentially. The other problem is that if your server has more than 10 to 20,000 people at a time, then you've got a load problem. You have to then offload that to like Azure, SignalR service, something else. So then we had Blazor WebAssembly. WebAssembly is fully client-side. Your C# code goes down to the client, which means you can't talk directly to a database. You got to use an API, just like Angular, React, or Vue do, but it acts the same as Angular, React, or Vue in that you have a full client-side experience with C#. So the same C# code you write for doing server-side stuff, you can use that same knowledge to write rich UIs on the client side. The downside there is it takes a little bit to load because of the fact that it's downloading your entire UI to the client. So what they did was they said, hey, what if we just mashed those two together and had both? And that's what Blazor web apps are. Blazor web apps, they even take a step farther and they have server-side rendering. Server-side rendering is when you have like an MVC or a PHP or something else where the server builds out the page using, again, PHP or MVC, but then it just sends the client HTML and CSS. But then if you want to do something, it's a full page refresh to go to the server and get the new page. That's server-side rendering. And Blazor can do that now, which means it's very fast. That's a very fast interaction. But then we have auto components. So just a little bit on your page can be interactive. Because your whole page doesn't necessarily need to be interactive, just a little bit. But that little bit can be an auto component. What that means is, at first, it's a Blazor server component, which has that SignalR connection back to the server. But behind the scenes, while the user is using it or while it's on the page, it downloads that same component as a Blazor WebAssembly component, and then it swaps them out. So now you have a very fast load of a SignalR component, but then you have the offline capabilities, or at least the faster capabilities with no connection to the server of a Blazor WebAssembly component in one component the user never knows. So it really elevates the game, and really, if you're talking about web development in C#, I think this is the place to start looking. I'm not saying every website should be Blazor, but I'm saying if you're going to do a C# website, that's the very first place you should go. I don't see a need for MVC hardly at all except for legacy. Okay? I don't see a need for Razor pages hardly at all except for legacy, because this has covered all those eventualities, but also gives you the ability to elevate and bring down components as you need to fit your future needs, not just the needs of today. Okay, so that was the top 12 in a lightning round, but now I have 6 more, because why not? I actually said 15 in the talk. I gave you 18 because bonuses are good. So nullability. Learn how to use nullability in C#. People complain about how you now have green squigglies everywhere, where it says, this could be null, and you're like, stop telling me. But what that's doing is Microsoft said, hey, what's the #1 reason why applications crash? Nullability. So I said, what if we just create a tooling that told you when there might be a problem so you could fix it? And all the developers said, let's ignore those problems until they become problems. And we still crash our applications. Learn how to use it. It's awesome. Upgrade improvements. It's easier than ever to upgrade your application to .NET 9, .NET 10. With .NET 9, they've now extended the STS, a standard term support version, from 18 months to 2 years of support. That may sound weird. What that does, that means that when you upgrade to .NET 10, you have 3 years of support. When .NET 11 comes out, in 1 year later, you'll have 2 years of support. What does that mean? You can upgrade to .NET 11 and have the same amount of support as you do for .NET 10. So that way, you can more easily upgrade to the next version and not worry about being outside the support window. And the upgrades are super easy. The biggest problem is your code, which means if you upgrade more often, you'll have less problems because you can fix them when they're small. Wait until they're large and it's kind of too late. All right. Performance improvements. Every version of .NET makes things faster. .NET 9, optimize the for loop. That's awesome. I mean, it's a tiny little thing, but we optimize the for loop. So, anyways, file dialogues in WPF are finally WPF file dialogues, not WinForm dialogues. Native AOT. For those of you who want faster performance on startup, etc., native AOT. Quick Grid is part of the new change as well, and tons more. Lots and lots more. And this is all before .NET 10. This is all .NET 9 back. So this is all stuff you can use today and hang on to your butts because .NET 10 is coming with lots more changes. So I encourage you to keep up to date. There's the slides if you need them. But otherwise, thank you for being here. I'll be here. Ask questions. Feel free to shout out and etc. All right? Thank you. And don't forget, there is a rating system for these sessions. You feel free to give me the thumbs up or thumbs down, yell at me. So you want to yell at me in person, though. So.
Thank you.
Uh-huh. And
Right? Okay. I mean, is that important? I don't want to mess things up. Okay. Just tell me when we want to start, and I will start. How's that? Sweet. Excellent. Trying to do a new thing. Now I messed it up. There we go. What is today? Thursday. Happy Thursday, everybody. Is this anybody's first time at Commit Your Code? Yes? What? Look out. You guys are awesome. Who's a Commit Your Code alumni? Back couple? Okay, came back. Look at that. All right. We're going to move fast through this. We're going to, for the next 25 minutes, talk about 10 reasons your software sucks. Okay? Why only 25? Or sorry, why only 10? We only have 25 minutes. Okay? The reality is we're really not necessarily talking specifically about what makes bad code, but 10 engineering practices that everybody should do if you're a professional developer. And if you guys want to try that side, you'll see so much better, I promise. No, it's not even close, because I'm standing in the way and I'm not transparent. I'm very opaque, I've been told. So, but that's a mouthful and doesn't really connect. So that's why we're going to talk about, that's it. Okay, so let's tell a story. Let's say you wanted to build a shed for your backyard. Has anybody ever built a shed? Okay, look at that, a couple of you. Okay, you could tell me everything I'm doing wrong later, please. I am not good with actual construction tools. Okay. What are the things you would need if you want a really nice shed in your backyard, right? Obviously a saw, a drill, a hammer, those kinds of things. Maybe you want to put in a good foundation, so you're going to lumber, concrete, windows. Maybe it's a shed you're going to spend a lot of time in, so you might even run some electrical and some pipes and some plumbing, right? That's a pretty nice shed. Good, nice, well done. Okay. Now, what kind of tools would you use if you were, say, going to build a building like this? Honestly, a lot of the same kind of tools, right? It's going to be concrete, wood, plumbing, electrical, saw, hammer, right? Kind of the same tools. What's the difference? What's the difference between a shed in my backyard and, a giant building? The scale, and I would also say the engineering practices and discipline that's along with it, right? I have to put a lot more, even though the tools might be the same, there's a lot more discipline and engineering practices that go into something of that scale. Now, let's say you want to build a personal blog. Maybe you'll use Blazor, right? We talked about Blazor web apps in the last talk. Maybe you'll use PHP, right? You're probably just going to go straight to WordPress, okay? Maybe you'll use .NET. Maybe you're going to use Java or Node, right? Or React, right? So sure. And that's fine. Any of those tools, you're going to build some kind of personal blog. It's great. Kind of like the shed in the backyard, right? It's like a personal project. Now, apply that same thinking. You're going to build an application that's dealing with 1 million or 1 billion transactions a second, and it's people's money, right? All of a sudden, what's the difference? I'm probably going to use the same tools. I'm probably still, okay, well, it's .NET. I might build it in .NET. I might use some other tool, but it's that engineering discipline and practices that really change between the scale. And so my encouragement is, as a developer community, we want to grow to be software engineers, okay? And so, or at least adopt software engineering practices. And that's really what I'm focusing on here. Now, this talk is not too deep. This is like the easy, like the low-hanging fruit, right? I spent years as a consultant, and you could walk into an organization and very quickly start to kind of run through a checklist of items and find some pretty big gaps that could, and you think, oh, if we could adjust this, it's going to make a big difference right away. It's kind of like if you had a friend that kept having like money problems, and you said, well, show me your budget, and they said, what's that? Be like, I can help, right? Here's maybe something that we could think about. We're not going to get too deep, though, which is nice. So we're going to handle a lot of things very quickly. Also, think of this as like a big picture directional talk. So there's probably a lot of things we'll hit on, and you'll think, yeah, I do that, ooh, and we're going to find those gaps. Use that to help set the direction, maybe an area you want to grow in this year, or help kind of direct kind of the sessions that you attend for the rest of the conference, right? So that's the idea. We're going to try to cram 25 years of experience into 25 minutes, all right? My name is Caleb. It's nice to meet you all. The big buckets we're going to drill into, coding, engineering, and growing, right? Growing because why? The cheese is always moving. If I were to drill into each of those a little bit more and say there's 10 things, right? It's really know your users, kind of think about from their perspective, code correctly is my encouragement, code well, code securely, right? We'll talk about source control, automated tests, automated pipelines. Think about the processes that you follow, how you work with people, and continuous learning, right? If you wanted to take a picture of one slide, although we are going to publish them, this is the one. Master your craft, user experience, whether it's OO or functional or just, again, think about the code, craftsmanship, secure code, right? Agile processes, work with people, always be learning. Like that's my battle cry that I'm really hoping to leave you with. So you could very quickly look at these and think, ooh, how do I grow in that area? Okay, nice to meet you all. Let's talk later. Okay, you guys ready? Buckle up. Let's move. We're going to do this. All right, so when we talk about master your craft, I'm going to say there's 4 big areas I would drill into. Okay, user experience. I've spent time leading user experience teams in the past. My degree is in digital design, which is kind of weird. It's never something I've done professionally, though. But we'll talk about user experience. Code, I'm going to expand on that a little bit, craftsmanship a little bit, and then we're going to talk about some secure code. So really that's know your user, code, try to learn how do you act. We have a big room here. .NET, okay, half the room in the .NET track. I love that. Thank the rest of you for coming. Java, okay, see, Node, JavaScript, thank you, TypeScript maybe. Okay, do you feel like that, like you've mastered your language, mastered your environment? I spent 1 year saying, I want to get better at keyboard bindings, like learning how to use my IDE without grabbing the mouse, right? So just think, what is the area you want to improve in this year? And I would say learning to really code within your language, whether it's object-oriented, functional, procedural, there's a time and a place for the right environment. Here's a tip that's not even in here. The more functionally pure you make your methods, regardless of your language, the easier they will be to test, right? And probably a little bit less error prone. What do I mean by functionally pure? I put in an input, I get an output, right? Whether it's or multiple inputs and I get an output, but it's always the same, right? And there's no side effects, right? So functionally pure, worth looking at more later. All right, clean code patterns. Don't repeat yourself, dependency injection, solid. Really, these are ways of thinking about, okay, now that I know how to use this platform, how do I use it well, right? Why are things like patterns important and understanding some patterns as a professional developer? Have you guys ever been to the doctor? You ever look at how much money they make? It's ridiculous. I mean, I love my doctor. I have good doctors, okay? But I went to a doctor once because if my skin was so sensitive, if I did a mark, it would turn red, okay? Right? Weird. And so I went to the doctor and he goes, oh, you have dermal scriptulitis. I was like, oh, how long do I have to live? What? What does that even mean, doctor? So, well, derma means skin. Okay, well, yeah, I got that part. Scriptulitis means you can write on it like a pen. Dude, I told you that when I came in, right? Now you're billing me to just say the same thing I said, but in Latin, right? What? I think of code patterns are like that. They're proven solutions for known problems. And it allows software engineers to kind of shortcut describing the pattern to just getting to the name so that we are on the same page, right? It also, you want to avoid the Pokemon pattern, which has got to try them all, okay? But it's good to have knowledge and learn so that when you confront some of these problems, you're like, oh, I was building one system once and really got I was like, how this is going to be, and a friend of mine said, I really think you should apply the state pattern to this. I'm like, really? I had never used a state pattern before in my life. Looked it up. Holy cow, it was a perfect fit. Simplified my code in the scenario that I needed, right? So think of patterns are like, what are those, again, proven solutions that I can know about so that I can learn to apply them in the right place at the right time to get the results I want. Okay, we're going to talk about secure coding in just a second. First, I want to talk about UX. And listen, I spent years leading a UX team. I've talked about UX at different times for about the last 20 years. I didn't want to talk about UX, but somebody built this application and I can't not talk about there's tabs. There's more to this. There's tabs you can click through and like, oh my goodness. Not only that, but then Microsoft decided to put the stop sharing button right next to the leave button. Okay, right? How many? I'm not the only one. Yeah, okay, I know where'd he go, right? And then schools decided this was an appropriate kind of app to pay for your children's education. I literally reached out to friends. I said, what are the worst apps you struggle with that are real apps today that you're dealing with? And she didn't even waste, she's like, this, I have to log into this thing every month. Can you call them? It's this school district. I don't want to say which school district it is, but you get the point. All right, so user interface is like a joke, right? If you have to explain it, it's not that good, right? If you were to look up user experience, and again, any UX people in here? There's maybe, okay, yeah. Wear multiple hats, perhaps, right? So people think of UI, not user experience. There's so many analogies. You go to like the Google and the images, and there's so many, okay, they overlap this way, they do this. I will tell you, for me, I simplify things by I align with my man Tron, right? I fight for the user, okay? That goes a long way to thinking about the kind of work that you're doing and how it impacts the people that are using it. And those aren't always, end users. Sometimes those are other developers, but thinking about then the developer experience and what it's like for them to work with the thing that you're building. All right. So I love, these are just some of the top hits. Talk to one user, you start jumping to solutions. Talk to 5 and start maybe understanding the problem. All right. Just some ways of thinking here. This friend of mine, Jared Spool, he has a company called User Interface Engineering. He tells the story of the $300 million button, okay? So I'm gonna give this to you very quickly. He does a much better job. In essence, there was a company that came to them and said, hey, we have a website, we sell e-commerce sites, could you guys come take a look at it? We're doing pretty good, but come take a look at our stuff. And they came in, and first there was no metrics, there was no telemetry, so they wired it up. A UX group, but the first thing they did was wire it up for some telemetry. And they saw there was a huge bailout rate. People would add stuff to the cart, and then they would go to check out and then leave. They're like, well, this seems high. Let's go take a look at this and go talk to some people. And they realized they came back and had a different approach, and they made one change. Okay, you see the screen? Can you spot the change? Here it is. I'll do it again. Ready? Because they realized, they had login and register. People were like, whoa, I didn't want a long-term relationship with you guys. I just wanted to buy my stuff. I can go buy my stuff somewhere else. And by saying continue as guest, right? That's a change. But by adding continue as guest, the number of customers purchasing went up 45% in the first month. That was like $15 million, which was about $300 million in the first year. Yeah, user experience matters, and it matters to a lot of things, including the bottom line. Okay? Have you guys ever noticed software tends to get complex? Don't do that. Keep it simple if you can, right? Fight for that. I love this quote by Albert Einstein, right? Any intelligent fool can make things bigger, more complex, more violent, right? But it takes a touch of genius and a lot of courage to move in the opposite direction. Think about that in your code. How do we keep our code simple, clean, easy to maintain? Right? There's 2 types of code that you will write in your life. This isn't even in the slides, but this is just extra and free because you're here. Right? 2 types of code. There's code that does stuff and code that decides what to do. And that's really it. And if you can keep those things a little bit separate, manageable, maintainable, it keeps your things a little bit tinier and makes them easier to orchestrate. Right? So we think about the flow, and we're building Lego blocks that then we're orchestrating. So always code as if the person who ends up maintaining your code is a violent psychopath who knows where you live. Scary but good advice. Friend Corey House made this statement. I really love this. Clean code at its core is about 2 things. Make the implicit explicit, right? And decompose big problems into small pieces, right? If you guys have never thought about this, making something new doesn't cost anything, it's super cheap, right? All the maintenance is downstream, right? So this is why we want things to be clean, simple, maintenance. This is where you spend time and money, and it's the long tail of your software, right? Which is one of the reasons sometimes AI is scary, because it's so cheap to make new things, and sometimes it gets hard down there, right? So you have to be really diligent on those. All right, let's talk about writing secure code. I think it's really important. We are in Texas. Okay, so what do you guys notice about this? There are no silver bullets, okay? So there's no one size fits all. There's no this one thing. Do this one thing and your code will be secure. So that doesn't exist, right? You're building software, you're releasing it into the wild. The cost of that is eternal diligence. Being focused on keeping the world secure and making sure that your stuff isn't all of a sudden making people vulnerable to challenges and issues that are out there. If there were 3 things that you were going to say about making more code secure, what are those 3 things? You can let it resonate, you can let it think. I'm going to give you my 3. 1, I say play in a sandbox. That really is about having security in depth or security in layers, right? So minimizing the impact of if something happens, right? So I'm trying to isolate things from each other. And I will say passwords are evil. Okay, so how do you get rid of passwords? You start running your code under identities, and you can start thinking about OAuth, and you can think about federated systems. But as much as I can get rid of having passwords in places, I try to, and also all input is evil, not just passwords, input in general. And so really comes down to being aggressively aware of what my system is doing. Okay, so passwords are evil, yeah, because they get out there, right? Trello is not a great place to store your passwords. It will get on the internet. There's a X account called like I Need a Credit Card, and it's literally scrapes people that take pictures of their credit card because they're so excited. And so it's like that's the account, I need a credit card, and it's don't put things out there, right? So don't have a password in the first place. Passwords are evil. I will say input is evil. We all know Bobby Tables. If you don't, you can kind of get familiar with Bobby Tables later. Fantastic. I had 4 kids. I didn't get to put SQL injection to any of their middle names. Please. Anyways, yeah, so don't name your kids Robert, apostrophe, parentheses, semicolon, drop table students, semicolon, dash, dash. But if you do, let us know, because that would be hilarious. I would love to see that on a birth certificate. But, think about other things, right? SQL injection isn't just for your kids' names. Are there real-world scenarios where you're taking down systems because of, what things are not guarding their input because they assume, I'm just reading what's on the front of a car driving by, and that should be fine. Right? What could go wrong? If you guys aren't familiar with OWASP, right? So the Open Web Application Security Project, worth taking a look at. I will say the statistics aren't good. As an industry, we're really not doing well at keeping our industry safe and secure. It's something we want to do better at. This is the top 10 list. I'm not going to spend any time on this right now. Just know it's there. It's worth exploring. And you can ask yourself, is my code secure? Am I making things vulnerable that shouldn't be? Right? Worth asking that question. This came out yesterday. I don't know if you guys have seen this. So inside of emojis, you can encode special instructions for the LLM and then copy the emoji, paste it into whatever LLM chat you're using, and it will often, in many cases right now, bypass the guardrails of the LLM. Here's what I'm saying. It's a changing landscape. There were no emoji injections when I was in school. Okay? like eternal diligence is our call. Okay. Let's get close here. So I love this quote from, does anybody know who that is? Jyoti Bansal. He's the creator of Harness, and before that, AppDynamics. He was on a podcast last month, and 50% of engineering happens after the code is written. I had to think, well, you're really continuous. I get the point, right? So when we write our code, what happens then? And so I didn't want to talk about source control. I want to talk about automated tests and pipelines. I was at a company, I'm not going to say which company, but it was like 6 months ago, and you can go find me on LinkedIn. And I thought, we don't need to talk about source control, because you're in GitHub, right? You all are professionals. You all know. And someone pushed a product into the entire organization on every single Mac in the organization, and from the engineering group, right? And it was a really cool app. I wanted to contribute. I said, hey, where's the code? It's in OneDrive. Or I think he said I put it on the SharePoint. And I was like, what? Why didn't you put it in Git? He goes, should I? Yes. Right? And I was like, why? Why did you do that? He goes, well, it was easy. Okay, so let's talk about that. So when we talk about automated pipes, builds, delivery, we'll get into this. So evolution of source control, right? A lot of you don't remember the days of zip files. Thumb drives are awesome, right? I backed up my code. That's not a good file share. No, that's still not. SharePoint was easy. That's how bad things happen. You guys can't see the slide from over there, so it's funny. And really, what we want to get to are things like Git, right? What we want to get to is where I can actually branch and merge and have a release strategy. That is the stepping stone to getting into automated builds and continuous integration, right? So from an engineering perspective, and today, GitHub is free, and there's no reason to not, right? I'm not going to spend a lot of time on this. I'm just going to say, think about what your branching strategy looks like. Think about how you're going to approach that. One of the things I love about this, what happened to feature dev 2? I don't know, we didn't care. I was at a company once the night before deployment and they were backing things out that weren't done. That's nuts. Are you kidding me? What, just keep, but that's not how they were handling things. I would say consider things like Git flow, trunk-based development. For the last couple of years, I've been doing a lot more trunk-based development. It was really sketchy, and I was nervous at first. I'll tell you, I've moved to that side at this point, so it's a fun thing to talk about later if you're like, what's the difference? Here's a big anti-pattern I've seen in a lot of organizations, where their branches match their environments. Stop it, okay? We can talk about why. You don't need a branch that says prod, and a branch that says, QA, and a branch that says, no, okay? There's other branching strategies. That's not one. That just means I don't understand source control, okay? That's a whole nother conversation. Source control makes your life easier as a developer. The fact that it's backed up somewhere away from your machine, that's just a happy byproduct, okay? Even if you're a team of one, the fact that you can branch and experiment on your local machine is amazing, and you want to jump in on that. Of course, XKCD, right? This is Git. It tracks collaborative work in projects through a beautiful distributed graph theory tree model. How do I use it? I have no idea. Just memorize these shell commands, and if something doesn't work, delete it and download a fresh copy. That's actually pretty accurate, right? So I love it. All right. I started working at a company where my first job was the gate scanners, right? Have you guys ever been to theme park? And I said, how do I unit test these? And I had a gate scanner hardwired into my cube. These are not unit tests, okay? If beep, beep, oh, test failed, right? Like that's, how do I know that these wheels are round and are gonna roll? If I have to get out there and push on that skateboard and eat cement to find out if they work, that is not a good test. Okay? That manual testing. I want to pull those things off. I want to look at them. I want to inspect them in isolation at the unit level, right? And then I want to automate that so now I can run thousands of tests at once with the click of a button or automatically every time I check in code, right? We're not going to spend much time talking about TDD and BDD, but if you're not testing your code through automated tests, you need to think about how your code is getting validated. And just because you hit F5 and it runs, that doesn't cut it, okay? All right, I love this quote. This is a friend of mine, Matt, who this was literally from like 10 years ago. Your test is not valuable when it passes today. Your test is valuable 2 months from now when it fails again, right? So when we talk about engineering, if you're a team of one, this is still valuable, but as your team grows, this is infinitely more valuable, are the ways you handle your codes. This was in 2010, yeah, 15 years ago. Okay. Automated unit tests make up one of the core staples in reducing technical debt and improving a team's overall code quality. That was in a book, so you know it's true, regardless of who said it. All right. Real quick, evolution of testing. I test my app, right? It compiled, didn't it? I have units, and when I'm using dependency injection and mocks and making sure I'm really specking things out, maybe now I've got continuous integration. Maybe I'm doing red-green refactor. Okay, so we can talk about actual TDD, not just automated tests, but test-driven development, or something more like BDD, where now you're doing executable specifications, right? Real simple there. All right, there's a bunch of things I put in this pipeline here. I'm not going to talk about those. I am going to tell this quick story. This is from 2016, years ago, okay? So this was a company that had deployments. They pushed it out as a manual deployment, and on the night of production, out of 8 servers, they hit 7 of them because it was manual deployments. They lost $45 million in 45 minutes, sorry, $400 million, and they're out of business now. Go watch the video, it's worth it. The link is in the slides. All right, automate all the things. That's all I'm going to say about that. All right, we're going to wrap up here. Think about how you grow. You're at a conference, excellent. that we're in a world where the cheese is always moving. The way you do things, like from the past, where maybe plan everything and then do it, versus plan, do, plan, do, plan. What happens between the plan and the do? You learn. You learn by doing, right? Plans are worthless. Planning is invaluable. I want to move through because I know we're at time and I know we're moving fast. Think about how you do processes. Think about how you work with people, right? There's so many things there with Scrum. There's a lot we're moving past. I apologize, but you know what? Scrum is simple. That doesn't mean it's easy. This is where I want to end. Not on giving you more advice, but it's this. Always be learning. If there's one thing you take away to always be learning. Continuous learning is the industry that you're in. Okay? What you learned in school is probably not going to be valid 15 years from now. It might be valid, but it may not be the main thing anymore. Sucking at something is the first step to becoming sort of good at it, right? If you just get a little bit better every day, it makes it. If you get a little bit worse, that also makes a difference. So let's focus on getting a little bit better every day. So y'all, thank you so much for being here. Be passionate about what you do. This is going to be a fun day, and it's going to be a lot of
learn a lot about the language and how you program based on the changes that came in C#, right? So Microsoft, they released this language called C#. It had a bunch of features, and then they did a lot of investment, right? They have options to put their money anywhere. They have a million different things they can do, but they choose very specific things. They spend like thousands of dollars developing C#, right? Maybe even hundreds of thousands of dollars. No, it's millions of dollars. And I think by looking at these features, when they add them, what they added, that gives us a good inclination on what Microsoft expects us to do with the language, right? So we'll get started. So this is me. I'm Ken Versa. I'm a software engineering manager at NET. I'm an ASP.NET Insider, which used to be a really cool thing, but now ASP.NET is open source, so everybody's an ASP.NET Insider. But I still get to put the title on my resume, so I'm still putting it on the slide. I started as a software developer in 2001. I'm a co-founder of Lincoln Code. I'm from Lincoln, Nebraska. Lincoln Code's a meetup. I hope you guys are attending meetups. They're very valuable, especially now in the climate we're in, to build your network. I hope you guys are doing that. If you're not, definitely start going to meetups. I'm also co-founder and organizer of Nebraska Code, which is a software engineering conference in Lincoln, a lot like this, but in Lincoln, and Great Plains Game Festival, which is kind of more my passion. That's a tabletop game festival, board games, role-playing games. I love that stuff. We had about 1,000 people last year, so it's a big deal. A lot of other people love it too. And I'm a father of 5. That's all you need to know about me. All right, so short history of C#. It was January 2002, and Microsoft needed a simple, modern, object-oriented language to compete with Java, right? Java had got released. It took the world by storm. Microsoft saw the future. They're eating our shorts. We got to do something. They came up with C#. Right, and C# was very bare bones. It was classes, structs, interfaces, events, properties, delegates, operators and expressions, statements and attributes, right? Like all those things that you need to have a modern object-oriented language. If it was me, I would have been like, I'm done, right? But Microsoft, a little more ambitious. They got to work and got to version 2. Now version 2 was groundbreaking, right? Version 2 had a lot of things that Java didn't have, right? We have generics, didn't have for 8 to 10 years. Generics, partial types, anonymous methods, iterators. I'm going to go ahead and go into these a little bit. And I want you guys to see what's going on here, right? This is Visual Studio Code being controlled with a clicker. Are you impressed? This is the coolest thing you're going to see at this conference, controlling Visual Studio Code with a clicker. It's not, but it's still cool. So iterators. So I just want to take a look at iterators real quick. So the old way, in C#1, if we wanted to iterate over a collection, right? We've got a string. I've got an array of a string of names here. I had to do this kind of junk right here. For int I is equal to 0, I less than 5, I plus plus, and write it all out. Iterators give us this pattern right here, right? Where now I can just say for each string name in names, and then I can use that name as a variable within my code. So what does this do? Why is this better? Well, what this does is there's a lot, now this is a simple example, right? But there is a lot of room for error in this, a lot of room for bugs. Iterators just eliminates a whole class of bugs. It's also more readable. You get a lot more meaning in the code that you're writing. And we're going to see a lot more of that going forward. All right, 3 years later, we get version 3. Now this is a groundbreaking version of C#. It's got one of my favorite language features, and I hope it's one of you guys too. I'm assuming most of you are using C#. It's called LINQ, right? Language Integrated Query. And LINQ is absolutely groundbreaking because it takes functional paradigms and it puts it in an object-oriented language, right? It hadn't been done before. A lot of these features we see, query expressions, lambda expressions, expression trees, those are all the basis of what makes LINQ work. And I know this was 2007. I was talking to Java developers in 2020, still didn't have a LINQ-ish thing. So it was groundbreaking, it was ahead of its time. We get partial methods, just like a ton of super cool things. So let's go ahead and and we get extension methods. I'm sure all you guys are familiar with extension methods. What I love about extension methods is, I feel like extension methods are like one of those tools that that everybody at some point, like they grok it. And then like all the code they write for the next year is extension methods, right? They go through like their extension method era, like they're Taylor Swift, but it's code. And you can go back later and you're looking at your code, you're like, okay, I know when I wrote that code because I was writing everything in extension methods. But extension methods allow you to add functions to code that you might not even own. Now, my example here, I'm adding a word count into a string, right? So if we have a string, I can now call .word count, and it's as though I added a function, a method, into the library, the .NET library itself, which I didn't, right? I can just add it on here. It's very, very cool. And then we also get link itself. So in the old days, right, before version 3, let's say like we have an array of fruits here, and what we want to do is we want to go through that array of fruits, and we want to find the first fruit that starts with O and return that. This is kind of what we had to do, right? So we're using our iterator we just talked about, right? Our string fruit in my fruits, we go through each one, we check what's the first letter, is it an O? If it is an O, and then set that variable to that fruit, and then break out of this loop. Link allows us to do this crazy stuff right here, right? I can just say my fruit, which is that array of fruits, where I can put a lambda expression there, x is equal to x dot starts with O, give me the first one. Right? So all this code right here, these do the exact same thing. They're going to return the exact same thing. But this one is way more succinct, right? It's one line of code. I mean, I have it, whatever. It's one line of code, and it just eliminates all the chances here that I could write bugs. But not only that, but it adds a declarative paradigm to it, right? So instead of me saying, this is what I want you to do, computer, do this, look for this, do this. Now I say, this is what I want, you figure out how to do it. And that's very powerful, right? Okay, now version 4, we don't quite get that many cool features in version 4, I think because Link was so big. They were working on Link so hard that they gave us a couple things in version 4. We get dynamic, which I don't know who here has used dynamic, right here, this keyword. It's kind of interesting to me, because this is kind of the first feature they added that actually gives you the opportunity to write new bugs and write more bugs. Right? Dynamic does not decrease bugs at all. It's exactly the opposite. So what dynamic does is you're kind of telling the compiler, don't do compile time safety checks. Just trust me, I know what I'm doing. So in this code right here, this code compiles, right? So I'm taking my variable, which is obviously just a string of hello, and I'm asking for the month method on that. Well, I mean, does string have a .month method? It doesn't. This will compile, and it's like, all right, YOLO, go ahead. Of course, when we run this, we're going to get an error like, I don't know what the hell you're doing. So mostly dynamic. I mean, there's very small use cases for it, usually like schemas, JSON schemas, XML schemas, when you don't necessarily know what's going to be coming in. Well, you do know, but you can't really. So there are uses for it, but it's just kind of an interesting feature that was added. We also get like named arguments. So now, when you have like a list of parameters, so it used to be, as we pass values into a function, we might have like 15 different parameters that are there. And I've got to pass them in according to where they are in the parameter list. Now I can just say, that parameter of last name, make it this. That parameter of presentation, make it this. And I don't have to, it's a nightmare when you got 15 and you got to put the empty spaces in the right spots and try to line everything up. Just very, very error prone. Named arguments allows us to get away from that completely. All right, now version 5, August 2012, we get async. And async is huge. This is another huge feature. And I think this is fantastic because if you think about 2012, like this was before Docker and Kubernetes and it wasn't before the cloud, but it was before everybody was using the cloud for the most part. And they were already kind of predicting the world that we're writing software in right now, which is, I hope you guys are doing that too, like everything's async, right? I'm assuming that I've got pods and I've got 30 pods and a pod might close down and I can't assume anything about my infrastructure. So everything is async, and they predicted this way back in 2012, which was fantastic. And async is a huge topic. Like you can do 8 hours on async, so I'm just going to skip it completely. The async is a keyword. That's the important thing to know. So then we get to version 6, which is July 2015. This one is kind of, we're starting to get to the life cycle here, where like a lot of those, a lot of the groundbreaking features have been introduced, right? So now we're kind of just nibbling away at the edges. We get a null propagator, we get string interpolation and exception filters. We got a couple cool things here. Exception filters, I don't know how many of you have used these. I've known a lot of people that didn't even realize you could do it. But now you can, instead of, you used to be able to do this kind of code before, like depending on what the exception is, we're gonna return different things, but you gotta do an if statements, right? So you have like a catch and then like this long if statement. Now we can filter our exceptions based on pretty much anything within the exception itself. We can use a when keyword to do that. Just kind of cleans it up, makes exception filtering a little cleaner. We get expression-bodied members, which is what I like to call the fat arrow. You guys call it the fat arrow, the equal sign and the greater than, which just kind of a nice syntax that you can use. But we get the null propagator, right? So what is the null propagator? That's this guy right here. So you have my presentation, it might be null. If it's not null, then grab the description. Unless the description's null, and then grab the short description. So this pretty much, we used to be able to write this code too, right? You just have like, if presentation is not null, then if description is not null, then, and you have like this long, now they just create an operator here, the null propagator. Very, very cool. And lastly, string interpolation. So that's when we're using, with a string, we're using a little $sign in front of it, and then we can use variables within the string. So before, you kind of might have to do something like this, where you provide all the values at the end, and then you refer to them by their number, where they're at, and of course if you got 15, it's a mess. Now this down here, this is a lot cleaner, right? We can just use the name directly and use the presentation directly. And string interpolation, as we go further, gets cooler. It gets cooler and cooler and cooler. Uh-oh. Okay. It gets cooler. By the time we get to C#13, you can put anything in there. You can put lambda expressions in there. You can do whatever you want. Back here, back in 6, not quite as cool, but still way better than it was. C#7, 2017, we get pattern matching and we get tuples, right? This is more functional concepts that they're pulling into the object-oriented language. And what they're doing is very cool, because they're taking different functional concepts. They're not making a functional language, but they're making it so that you can use the language, the benefits of each different type of paradigm, and use them together. So the tuple, here I have an example of a tuple. So this just allows you to kind of not do a lot of boilerplate, right? So we could have made a person class with an age and a full name, and then called it here and everything. That's a lot of boilerplate code to write. So tuple is great if you've got just short, quick, dirty data object that you just need to do some operations on. Then you can just do it as a tuple. We get the out variable, which can be used for various reasons. Then we get pattern matching though, and pattern matching is awesome. All the F# people love pattern matching. So pattern matching, when we first get it in C#7, it's very limited. And we're going to see later, as we go forward, lots more pattern matching, lots more places, lots more different ways to do it. But in 7, we pretty much get 3 things, right? We get the is keyword, name is null, right? So we can check if something is null. We can do a type check, right? So we might do something, maybe it's a string or maybe it's a Boolean, right? Maybe somebody's passing false as a string, and so I need to do something if they do that, but if they pass it as a Boolean, I need to do something else. Or numeric, maybe they might pass in an integer or a double or a floating point. I know it's a number, this is gonna allow me to just check the type and then do the correct action. And lastly, you can just do a discrete value check, which is just kind of a switch statement over that. Pattern matching, very, very cool. All right, then we get to version 8. This is 2019, and I love this because you see version 5 was async, and now version 8, it's this whole this is every little thing that we did, right? So there's a lot of things in here, a lot of features, but it's not anything that's fundamentally changing the the language. I think the default interface is probably one of the, there's two things I kind of really liked in this version. Default interface. If you look at this, I don't know how many of you use default interfaces. This is kind of interesting. This is an interface, and I have code in it, right? What's going on there? Right? An interface is supposed to be a contract, but I have code. I remember when this came out, a lot of people, this was very controversial. A lot of people were like, what are you doing? That's not what interfaces are for. The reason they did this is for backward compatibility. So like I might have a library that has an interface that other libraries have implemented, right? And now if I add methods to my interface, they have to implement all those methods before they can use my library, right? So you might want to pull down the new version of the library, and now you have to change 50 different parts of your code just to implement all these interfaces. Now we can kind of put a default in there, and now it's not breaking changes every time we change the interface. And we also get the null coalescing assignment, which is this guy right here. What all this says is if the left side is null, set it equal to the right side, right? We could have done that with an if statement, but this is just kind of a cleaner way to do it. So if my presentation is null, make it a new presentation. If it's not null, leave it how it is. All right, then we get to 9. Once again, a lot of performance, interop, a lot of fit and finish features. We don't really care about any of that stuff. But we do get records. That's kind of the big feature that we get in 9, which they're interesting, right? I don't know if you guys are using records or not, but records are intended to be used for data objects. They're optimized for data objects. They're immutable by default, right? So I could have had a class that's an animal, and then had a name and a is furry, right? Had all the properties and stuff. I can write all that just in one line here and make it a record. If you want to make it, you can make it mutable. That's what we're doing here. If you can make it mutable, you just have to specify that this can be get and set, right? That's how you would make it mutable. But I would recommend if you've got data objects that are just classes, and you're in that code and you're working in that code, switch them over to records. You'll get better performance. If you're already in the code, like don't go through all your code and change all your data objects to records, unless you have AI do it or something. But if you're already there, this is just kind of a nice thing to do. In C#10, we don't get a lot that's cool. We get global using directives. That's probably the coolest thing, right? So global using directive, in the past, you might have system collections in every single file. You might have like a stack of usings in every single file at the top. Now we can put all those in one file, and whatever's global in that file can be used anywhere. That's pretty cool. You get this file scope namespace declaration. So that kind of saves you from starting your code over a tab, right? So you have like your namespace that's over a tab. Well, now we use a semicolon instead, and now we can just start on the left side. Kind of small, but it's something. They did it. And we're also starting to see with C#10, actually with C#9, is we're going to the yearly releases, right? So every November, a new version of C# comes out. Like every November, a new version of .NET comes out, new version of C# comes out also. So we're starting to see, and I think that's why we're starting to see kind of smaller little bits coming into. C#11, this came out in 2022. We have raw string literals, which are really, really cool. We're gonna look at those. Required members are okay. So raw string literal, so here's kind of the old way we would do a string literal, right? We would put it in quotes, and then we'd have to do like a slash to get, for escapes and things like that. So a raw string literal, you do 3 quotation marks to start it and 3 quotation marks to end it, and then you could put whatever you want in the middle. You can put whatever you want. If I console line this, it will be tabbed over and it will be centered, right? So it does new lines, it does tabs, everything. So this is very, very cool. So I definitely recommend looking into this. Raw string literals, you started with three quotes. All right, 2023, we get version 12. We get primary constructors. That's kind of the main thing. We can alias any type. So I can just kind of create a tuple here at the type, use it as an alias, and then I can use it within the code. Do a using, so anything I want to do in there I can do. Primary constructors allow us to create classes, sort of like records, right? We talked about earlier about how records have a really nice syntax. I just include the properties in the function declaration or in the record declaration. Well, now I can do that with classes too. So before I would have had to have these as properties. It would have been 3 or 4 more lines of code. Or if you had 15 properties and you have 15 lines of code, all that's eliminated now. I can just put them right in the constructor. We get, oh, I almost forgot about this. We get the collection expressions are pretty cool. These are, you can just kind of create collections just like this, throw it right in there. Then we get the spread operator. This is actually my favorite part of C# 12, right? Because I had done a lot of JavaScript before that, and I love the spread operator. So if you've done JavaScript, you definitely know about the spread operator. Spread operator allows us to pretty much copy one array into another. That's those 2 dots right there. So like this array right here is going to be the values that are in this array plus whatever I add into on top of it, right? So it's just a very, very easy way to copy one array into another. In JavaScript, it's 3 dots. C# it's 2. Now we get to 13. This is the most current version. And this one, so there really wasn't a lot. This was a disappointing version, in my opinion. We get implicit index access, which I don't know, I've never needed to use this, but apparently some people really need it, so they added it. What this allows us to do is, if you look right here, use the caret in the array, and you're setting to the end of the array, right? So this data buffer, this right here, 8 would be assigned to the last element, 5 would be assigned to the second to the last element, 12 would be assigned to the third to the last element, 15 assigned to the 7th to the last element. There are times you need to do this, I guess, like maybe when you're doing games, I don't know. I've never really had to do it, but it's something they added and it was really hard, I guess. Params collection, you can now use params with any collection type, right? So now we can pass in spans into as collection types, right? And if you guys aren't familiar with spans are very fast, they're very efficient if you're doing read-only operations. That's another kind of thing you can do if you're in your code and you're using arrays or lists or something like that. You can make your code faster by using spans. Definitely check that out. We also have the overload resolution priority, which says essentially use this constructor. Like if you don't know which constructor to use out of these two, prefer this one. Now we have time for the future, which is C# 14. We get field-backed properties. We also get partial events and constructors, which I think are kind of interesting. So we'll go up to the top here. So we can now do like this employee right here. This is a constructor for employee, but I put a partial on it. And sort of what this is doing is this is allowing us to kind of add an interface onto a class, right? So whoever implements employee has to implement this constructor. Is kind of what it comes down to, and same with the event. So it's kind of like going the other way, right? So like default interfaces was putting code in interfaces. Now this is putting interfaces on code. It's kind of interesting. And then we also get a field code keyword here. So now you don't have to declare, so like right here I have a property, new hours. I don't have to declare like a new hours backing field. I can just use a keyword field and access that. And we get the no conditional assignment, which is really awesome. I got 30 seconds. So this just says right down here, if this property is null, set it to new value. So that's what we're getting in 14. Last one. This would normally be questions. We don't have time for questions. But 15 is about union types. If you're familiar with TypeScript and you know union, that's kind of what they're looking at for 15. This is kind of a tidbit. It's not in here because we're not to it yet. But that's what they're looking for, is that we can now have union types in C#. That's my time. I did it perfect. 25 minutes exactly. Thank you.
Hello. Hi, welcome everyone. My name is Arvind, Arvind Chigrala. I work as the Vice President of Engineer at Extero. We help law enforcement, like criminal cases, things like that, right? We have been using AI for a while now, right? But with all the latest advents, one thing I wanted to share with you, right, which I'm proud of the work that I'm doing, right? A lot of these law enforcement cases are about images, right? Images, videos, and trying to find the criminal within using those evidences, right? We recently developed something in the AI, right, where you can go and ask AI, right? I want every picture that has a dog in it, right? And so it's taking the text that you have put in, and it is trying to find all the images that have dog, right, and bring them back to the investigator so that he can look at those pictures, right? So that is where we are, right? So one of the primary things that I'm doing is we are making the transition so that we can help the law enforcement or taxing authorities or corporations, what you name. We are trying to help those. So today we are going to talk about primarily MCP, right? Model Context Protocol, what that is, how to use it, how does it fit into agentic workflow. That's what we are going to talk about, right? But before that, a little bit of context, right? Why do we need this, right? Why do we need MCP? So the primary reason there is today in the keynote, right? We learned that these LLMs are big, right? They have a lot of knowledge in them, right? A tremendous amount of training goes into it, right? And it is very hard to train those models, right? Lot of money, lot of time, lot of resources, all of that. So that's one of the drawbacks for the LLMs, right? They do a pretty good job, but that's a big drawback, right? And the ChatGPT 5, right, which is the latest, greatest of what OpenAI has, right? Its knowledge is only limited up to October 2024, right? So if you ask it anything, right, the base core model of it, if you ask it anything, it wouldn't know what that context or what that topic is, right? The OpenAI itself is building some more on top of it to give you the results. We will see what they are using, right? But the core model itself does not have more knowledge, right? So it's always behind. It's always running behind the time, right? And the model itself, right, it is very simple, right? It says, predict the next word that is going to come. All that it's doing is it's saying, what is my next word? What is my next word? What is my next word? That's all it is doing. Model does not have a lot of intelligence, or it cannot do any actions by itself. All it is trying to do is generating the next text, right? Now we will look at 3 different techniques that are available to us, right? There might be few more, right? So this is rapidly evolving. There might be few more others, but there are 3 techniques that I want to cover today in how we come across these 3 things, right? The first one is RAG, right? What RAG is, right? You can always go to ChatGPT or Gemini or whatever. You can give it a PDF, right? As long as it can handle that content, right? 1 MB, 2 MB, 10 MB, I don't know, whatever they can take. You can give it that document and ask it to analyze that document, right? And it will work fine, and it will give you all the data that you want, right? Summarize it or do more analysis on it or whatever you need to do, it can do it, right? So what we end up doing is, right, in enterprises we have gigabits of data. A lot of content gets generated, right? But we still want to use the LLM, right? So what we end up doing is we take all of our content, right, create what is called as an embedding, right? We create a number representation of our content. All the content that we have, we create a numbering system for it, right? And why that is important is we are trying to create a subset of data that we can take and give it to the LLM, right? We want to take, okay, I said, who is this guy or something I'm searching for, right? So you want to take relevant data, right? You don't want to give all 15 GB because LLM will not be able to process. It's too costly, right? You cannot give all the data. You have to give it a subset of data. The RAG is really that. RAG is you're trying to take your huge database you have, a lot of data, a lot of content you have, find the subset of data that is interesting for a given user's query, and submit that to LLM, right? Now LLM can do its magic, create a good report, add more analysis on top of it, you name it, right? LLM has all those benefits. It's going to do on top of that limited set of data. So RAG is really trying to take a lot of data that you have, compress that so that it is for that user query that he has given, and give it to LLM so that it gives you back the report. That's all RAG is, right? It is, there are a lot of tools out there that you could use to do RAG, right? Some frameworks, Llama Index, or few other frameworks that are available that make it easy. How do you generate the embeddings, or how do you generate chunks? How do you generate vector databases? All of that is already built in, so it makes it easy, right? Those frameworks are making it easy to do all of that work, right? But essentially, that's all you are doing. So that is about RAG. The next one, we are talking about the agentic AI, right? I want to draw here, right, this diagram here. Before MCP, right, all of your data, whether it is in Google Drive or whether it is in OneDrive or whatever, they all directly talked to the server or to the LLM here, right? After MCP, they made a unified interface so that LLM always uses that unified interface to talk to your server, and those servers are in turn talking to different data sources, right? So you are building these servers here. Here, these are different servers that you build, but the server connection to the LLM is constant. MCP is that, right? Model Context Protocol is a consolidated, a clear, simplified way where LLM is able to talk to the server that you built. That server can talk to whichever data set that's present out there, right? That's all the Model Context Protocol is, right? Once you go in and start trying to read about MCP, the nomenclature gets really little bit tricky, right? What is what they are talking about? So essentially, when you look at the Model Context Protocol, you have what is called as a client, an IDE, right? Like it's cloud, or you could take Google Gemini, or you can take Visual Studio Code, right? You have what is called as a host here, right? This is the host here, one of those, right? And within the host, there is what is called as a client, MCP client, right? And that client talks to an MCP server. This is what you will write. MCP server is what you will write, right? That MCP server can talk to any data structure, right? It can talk to a database, it can talk to a file system, it can talk to name it, right? It can talk to all of that and return the data back to the LLM. So it's kind of this, right? RAG, you took a subset of data and sent it over to LLM, right? Even here you are doing the same, right? What you are doing is you are reading the data from various different places and sending it back to LLM according to the query that was sent by the user, right? User input some query. For that query, the MCP server is going to look at your backend databases, your enterprise databases, right? And it is going to return the data back to the LLM, and the LLM will format it, it will add its own analysis to it and present the data out. So that's what MCP is, right? So it's not only about retrieving the data. MCP is not about retrieving data. You can actually do some, okay, let's book a ticket, right? MCP says, this is the, LLM could come back and say, this is the ticket that I found, which is very cheap, so let's go do the booking. So you can write an MCP server that's actually calling a web API, which is booking a ticket for on behalf of the end user. So that is possible, right? It's not just about data anymore. You could literally write a function that's changing the state of some, and it's doing the real financial transaction or whatever you name it, right? So it's both data as well as being able to do some action is where MCP comes in. So we'll get into a quick demo here. So this is cloud desktop, right? File, settings, developer. I'm just showing how do you develop your MCP, right? If you wanted to develop an MCP server, this is how you are going to do it, right? You come here, you hit the edit config. There is this cloud desktop JSON file. Open that. That's all it is, right? The MCP server, we give it a name, right? We are giving it a Python script, yeah? Okay. So all we are doing here is a simple Python script, and we are telling where the Python executable is, right? That's all we are telling, where the Python executable is and what script you want it to run, right? And I'll show you the Python code here. You are able to see it? Okay. So we have this utility called FastMCP, or a library. This is, you could just ask any code generation platform, it will generate for you. The important thing here is there is an attribute, or there is a nomenclature that you put, right? mcp.tool. Once you say that, right, this method can be called by the LLM. Based on the user query, LLM can call into this API, right? So you are giving the specification, okay, this is the function that I want it to call, right? Internally it is using JSON, right? When it is calling into our Python code, it uses JSON over RPC to call it, which is a generic, right? Whether you write it in C#, whether you write it in Python, Java, you name it, they are all using JSON over RPC, but within Python, that's how you register your function, right? You are just putting this nomenclature here. These are all the functions that LLM can call into, right? There is a tool, there is a resource, and there is a prompt, right? You can even send out a prompt. So that is the prompt that LLM is going to use when it calls itself. It is going to use that prompt to talk. So let's see. So this MCP is straightforward, right? All it is doing is given hello world, right? Given the word hello world, it is converting into various different languages, right? We'll go here. New conversation. Translate. Sorry. So I'll show you where you can actually see what it is calling and how that works, right? Hello world in French is here. See, the good thing is, we'll go here. I have added this additional semicolons or whatever, right? The LLM actually figures out that's not the part of the translation. It actually strips it out, right? Strips out those additional characters and only gives you the real translation. So the point being, right, you have your API, you get the data from your API, the LLM is going to add a lot of value to that API by looking at its content, by formatting it, or by getting additional data from various different sources and putting it all together in a format that the user can use it, right? So that's what the LLM is. If we go here, 1 minute, go to folder, logs, cloud, mcp.log. So you can exactly see what the LLM is doing, right? As LLM is making calls, it's actually logging everything out here, right? So it's telling it is looking up that. Let me see if I can. Go up a little bit. So right there it is using the MCP server, right? It started the server, it's contacting our MCP server. We didn't have to do a lot, right? All it was a Python script with few attributes that I had to add on top of it. And within those functions, you could do whatever, right? You could talk to any service, anything, and then retrieve the data back out. I'll just show 1 minute here. So one important thing here is the LLM is dependent on your comments here, the comments that you put here. It is dependent on that to figure out what that API is doing. Right? So it looks at this comment and it says, okay, this is going to translate hello world into a different language. So it knows, that's how it knows what this API is supposed to do. So the comments are pretty important for LLM to understand your function, right? Like you see, there is not a lot to the function, right? It is literally just going in from a dictionary, it is pulling out the corresponding word and sending it back out, right? Instead of that, you could have called in an API and retrieve the data back out. With that, let's go back into the presentation. So we'll talk about some best practices or security issues within the MCP architectures, right? This is so much easy, right? Given how easy for an LLM to call into an MCP server, right? If you are connected to a server, if you are connected to an MCP server that you don't trust, right? Or which can take your data out and you use it for malicious purposes, it's so much easier, right? Because LLM will call with all the data that it already has so that the MCP server can make the appropriate decision and send the data back out. So that is a big security risk, right? So when you are adding, right, in the screen where you added the MCP servers, you have to be careful that you are only adding the servers that are really, you know them, you trust them, right? That is important. And if you are, one of the things, right, these MCP servers are only useful when they are talking to other APIs or other things, right? So when you are talking to these APIs, you need some API key, some session key, or some kind of authentication and authorization, right? And you got to be careful with those, right? You need to make sure that they are recycled, they are encrypted, things like that, so that the no one is able to get into your credentials and APIs and all that, right? And what you expose, what are you exposing within your MCP server should be very measured. You don't want to expose whole world, right? You want to expose only limited set of APIs that you are really wanting to target, right? So that you reduce the general common sense principle, right? It is this, you are trying to reduce the surface area. And the other thing is you want to make sure you are logging, right? You are monitoring, you are tracing the API calls. So you understand the usage pattern, you understand any malicious behavior, right? I might go as far as saying that once the data is returned from your MCP server, you might want to validate the data being sent out and make sure that you are not returning the data that's not supposed to come out of MCP. Because they can literally prompt anything, right? The user could go in and prompt whatever he wants to, and in that response, the API could return any data that you are not supposed to, right? So you want to check the prompt as well as you want to check the data that's coming out of your APIs, right? That is the best practices. It's really simple, right? Once you get a hang of it, it is simple, but after that is where you need to spend all of your time making sure you put in proper checks and balances in place. And the last one is the small language model, right? Or we can even call it as model tuning. You can take a bigger model, right, and tune it. Or you can take a small model like Microsoft Phi or Google Gemma, right? It's a very small model. It only has like 30 billion parameters, 30 billion knobs that you can go with, and you can add additional data to it, right? So it has the base knowledge of the English language or whatever, right? But then you are adding more to it, right? You are adding your enterprise data or enterprise content to that model so that you can use that model, right? That is the third way of doing dealing with large language models, because they have some inherent fallacies. And I think that's all. Thank you.
Communicates to your REST API. Here's the input, and then this is the output that we expect you to use. Like, would you just stick with a Lambda there, or would you start with an MCP?
So I would probably rather do the MCP, because the API itself, I've tried a few times, it still has a lot of features. I can't consistently get it to work. I've used much too. They say they have support for HTTP, and they can, the LLM can directly call into HTTP, and they can use
In your version, you can upload a Swagger API to define inputs now as well, so that's why I was wondering. Okay.
Yeah, at least I haven't had like a lot of structures just directly going against the API. It always fails with one of the other. This is more consistent though. I will be
session is for hardcore geeks, so there's only going to be 2 or 3 of us in here.
So you're a principal engineer at CG?
Yeah.
CG Infinity?
Yep. So how many people have fallen off the stage so far?
So far, none.
None. Oh, well, I could be the. I'll be the first.
That we know of. Today called Wait What? C# Async Await Explained. It'll be going on in a few seconds.
Should I flip the switch?
Yeah, you can. Go ahead.
I'm scared. You told me to flip this switch. I don't know what exactly is going to happen.
Find out.
Just a little electroshock? Neuralize me? Uh-oh. Whew, okay. That was interesting.
It's not going to be as dangerous as async awaited.
No. No. Shall I start?
Are you ready?
Ready. I think I'm ready. So has anyone in here ever written some C# code? C# programmers? Good. Come on in. All right. And has anyone written an async await in your C# code? Yeah, right. This is bread and butter. We do it all the time, every day. We've probably written thousands of them. So I have a little confession. About a year ago, I was writing my 10,000th async await, and I was like, you know, I don't know if I actually know what this is really doing. I had sort of like a crisis of faith. And I went through kind of a personal journey of digging in and understanding it, and I was really surprised at what I learned. So now I'm going to take you through the speed run version of my journey through this, and maybe I'll get to surprise you, and maybe you'll learn something. Or maybe you already knew this and you'll be like, wasted 25 minutes. Anyway, so wait what async await explained. First, just a couple quick acknowledgements. I want to dedicate this to my dad, Larry Hess, who passed away this year at age 83. I really lucked out in the dad department. Thank you, Daddy. He was an amazing man, amazing father. I want to thank CG Infinity, my employer. They're here in Plano, super supportive of these kinds of activities. Really a very enlightened, great place to work. We're doing a little recruiting these days, so CG Infinity, you should look it up. Okay, so the first thing I want to do is ask a question. What is the point of async programming? Why do we even do this? So basically, async, we want to allow our code to do more than one thing at a time, to walk and chew gum, right? We just don't want to like sit in one place and be like, okay, start that and do something else in the meantime. Now, that style of programming has lots of names and jargon around it. People talk about parallel programming, concurrent programming, multi-threading, async, come on in, hey Ron, asynchronous programming. So these are all different kind of nuances and flavors of doing more than one thing at a time with your code. So the async version of that, it focuses on letting your code stay busy or responsive while you're waiting for a longer process to complete. You've kicked something off and you just want to stay busy. Okay, it's a little different than maybe parallel programming or some other things, but that's the emphasis. So that's very abstract. So let's bring it into the real world. Let's say that you're in Kyoto and you're hungry and you want dinner. So if you're going to get dinner in Kyoto, you're going to walk into one of a million cool little cafes, and there's going to be one of these kiosks. Maybe if you've been to Japan, you've seen this. You walk up to the thing, you make your selection, you put in cash, totally cash-oriented culture, no swipe and stuff. And it makes a little ticket, and then the guys in the kitchen get your ticket, and they make your dinner. Okay, so that's how you're going to get dinner in Kyoto. But let's say, just hypothetically, stick with me here, that you're also thirsty. You don't just want dinner, you'd like a drink. So, while the guys are cooking your food, you walk out the door down the street and you find one of the 10 million vending machines, drink vending machines that line the streets of Japan. You put in your 100 yen and you get a bottle of happiness, okay? Then you walk back down and you sit down and you enjoy dinner in Kyoto. So there are two ways you could implement this in code. The first one, this UML sequence diagram shows you the synchronous modeling of this interaction. First, my function, which is called getDinner, calls order food. And then it waits for the food. And then once it's got the food, it calls getDrink. And it gets the drink. And then you sit down and you enjoy your dinner and your drink. That's synchronous. Okay? And this is generally a waste of time. This is not what we want. What we want is overlapped, right? Asynchronous processing, where you put your money in the machine, in the kiosk, you order your food, and then while they're cooking it, you go and you get your drink, and then once both have completed, you sit down and you enjoy your drink. So that's what async gets us. That's what we're trying to solve. So let's write it in C#, okay? Let's just port that all, slam it right on into C#, see what it looks like. So I'm going to take you through this a little slow because the devil's in the details here. Can everyone see the text okay? I can try to, no, that didn't work. I don't know if I can. Okay, we're going to have to work with it. Okay, so we have our static HTTP client instance. Here's our main function, async task, get dinner in Kyoto. And it's going to await, order, drink. It's going to order dinner, await, order, drink, and then it's going to enjoy the dinner and the drink. And these are just the supporting functions. Order dinner is a REST API call to some server called restaurantkiosk.com, where we specified item 29 and the option was rice. And if we got that back, we deserialized our dinner JSON and we returned it. And then similarly, here's a drink. We order drink, it's the drinkmachine.com, item 7. And if the REST API call came back, we're like, cool, get me the JSON, deserialize it, and then we can enjoy dinner and drink, right? Okay, quiz. Which UML sequence diagram does that implement? The first one, sync, or the second one, async? It's covered in asyncs. What is it? Which one? Synchronous, synchronous. Anybody else want to vote? Okay. It is the synchronous implementation because when you call await in C#, the code doesn't advance to the next line until the result comes back. I don't want to say blocking, because blocking is a term that like smells like threading, but it basically is in this weird suspended state until you get the next one. So when I first saw this, I was like, wait, what? WTF, why are we even doing this? What is the point? What does this buy us? Right, that was the kind of crisis I had, the wait what moment. It's like, it is not doing what I think it's doing. I almost started going back and just ripping this stuff out and being like, I'm going back to synchronous. I don't want this, because it's a lot of work. So, okay, so we're going to dig into this, and the rest of the talk is explaining what it actually does and why you do need to do async await. But before that, I do want you to know that I ordered the chicken pork katsu. It was really good. Okay, so, sorry? Oh, yeah. I mean, like that's like regular Japanese. Japan is full of amazing, amazing food of all kinds, but like working person food, like after a hard day and you're just hungry, pop into a kiosk, cheap, get a giant plate of pork cutlet smothered in curry and call it a day. So, okay. So what does async await actually do? It's all about the thread pool. So I'm going to walk you through this. So in reality, your C# thread pool has tens of thousands of pool threads. But let's just imagine that you've got a C# Lite, okay, and they only gave you 3 threads. So we've got this sad little thread pool that contains exactly 3 thread pool threads. And you've written a server here, and whenever a request comes in, your server is going to start running some code, a task. Service that request. Well, as you may know, when you program in tasks in C#, you are given a thread pool thread. Okay, tasks run on thread pool threads. So what happens is T1, the first one, gets assigned to your task, and it starts running. Step 1, great. Step 2, great. And step 3 is the thing that's kind of slow, right? Maybe the call out to the REST server, something like that. So that one is kind of busy there, right? It's kind of, in computer terms, it's stalled out. And then 2 more requests come in. Okay, great. Thread 2 gets assigned, T3 gets assigned. They all zip through step 1 and step 2, and now they're all kind of holding out there on step 3. So what happens, see you, Rahul, have a good one. What happens if a 4th request comes in? Got a problem, okay? This is called thread starvation, right? Request 4 is out of luck. It cannot even start until a thread is assigned. So this is the problem that async await solves, thread contention, right? Competition for a limited resource, the thread pool. So let's go back in time. When that first request is serviced, and we call it as a task, and we await it rather than just executing the task, what happens is, when it gets to step 3, which is the awaitable step, the C# runtime creates what's called a continuation. That's your vocab word for the day, a continuation. And a continuation, you can think of it like a special bookmark, okay? So C# says, okay, that line of execution, that call stack, I'm going to bookmark it right there. The thread goes back to the thread pool, and I'm just going to listen for a magic signal that tells me, hey, you could rehydrate that one and pick up where you left off. So it lets the thread release and go back into the thread pool. So now, if you've got these 3 requests and they're all async awaited, all the threads are there, and when your 4th request comes in, hey, happy day. We have a thread pool thread available to service it. So that's what async await actually does. Now, just to complete this story so you have a full mental picture of like the life cycle, let's say that that magic signal happened, ding, and what that means is that for the request 1, it got the result of step 3, and now it's ready to move on. Well, the runtime says, oh great, we can continue. It clears the continuation, it grabs another thread pool thread, and it lets your code continue on. One really important fact that I illustrated here is the thread you started on may not be the thread you continue on. There's no thread affinity between a thread pool thread and a task. And if you have, like me, ever written multi-threading code that uses things like thread static, which creates affinity between variables and threads, you're hosed when you port it to this. It's really disastrous. So that's kind of a detail, but it's important to note that any thread that your task is running on, it'll change around. And you can do some tracing and see this. It's really cool to see how the system is allocating threads. Okay, so in summary, async await, just on its own, does not let your code perform multiple things in parallel or overlapped. Okay? That's not its purpose. What it does do is it frees up thread pool threads so that your server, your process overall, can be responsive and service many tens of thousands of concurrent requests. Now, I have an unproven hypothesis that the reason this is in the C# language is because the ASP.NET team had created this train wreck. They built ASP.NET servers that all of a sudden were maxing out the thread pool, right? And they're like, oh heck, what do we do? Oh, well, let's just change it all over to async await, and that way our ASP.NET servers don't bog down, and then it's propagated out, right? Because for a normal small app that isn't servicing tens of thousands, it probably doesn't really matter that much. But we are all writing code now that gets executed in the cloud, in Azure Functions, in Azure Services, and we should assume that in the background it is all running in Docker containers on Azure Kubernetes service, like it's all running in this highly shared environment, and we have no idea what the hardware resources are. So we have to use async await and play nice, because the people running that infrastructure assume that we are. Okay, so we have to do this, even if you think your app is kind of small or silly. Okay, so I have 11 minutes left. I want to just go through a couple of implications and analyses. Now, I've got a longer version of this talk if you're enjoying it. It's posted to my YouTube channel, and I dig into a few more weird nooks and crannies. But for 25 minutes, we had to edit it down a little. So the first thing is, what if you did actually want dinner in Kyoto implemented asynchronously? Like, because all of you are like, oh, that's what I want to do. How do I do it? So there's simple C# code to do it. You just have to write your C# a little differently. You have to say, okay, the way we implement it is we create the task. Dinner task equals order dinner. Got that task. Drink task equals order drink. Notice that we did not await them individually. And then we say await task.whenAll. And we hand it the list of tasks we're going to await. So you can tee up 1,000 tasks and just await all. And while you're waiting for them, your line of execution is not holding on to any threads at all, right? It doesn't matter how long those take. Eventually, they'll come back. So that's the proper overlapped, right, asynchronous implementation. This is a great technique. Okay, so if you take away a vocab word, it's continuation. And if you take away one code snippet, that's your code snippet. So the other thing, this is a little theoretical, but it's fascinating, and it kind of blew my mind. What makes something awaitable in the first place? So just going back to CS 101, you can talk about IO-bound versus CPU-bound work. Okay? CPU-bound work is work that relies on a core, on a processor, and that's usually very math-intensive. And you really are limited by the computation resources you have available. So building an LLM is a classic example of CPU-bound work, and that's why it takes so many processors to do that. But other things that I've done, like nonlinear regression, or giant matrix multiplication for supporting flow cytometric compensation, like sciencey, mathy stuff, tends to be very core intensive. I/O-bound work is stuff where you're waiting on a port, usually, possibly a file. In the old days, it was more file I/O. We don't do as much of that anymore. Where basically you've sent a request out over a port and you're kind of waiting for the result of input-output. And if you probably can't read all these, but these are like a whole smattering of C# namespaces and functions that are awaitable. For example, in system.net.http, you have HTTP client get async, HTTP client patch, HTTP client post. In Microsoft Data SQL client, you've got execute reader async or read async. Or in system.io, there's the file ones. In Azure Service Bus, you've got service bus sender.send message async or service bus sender.receive message async. And other weird ones, Windows storage, named pipes, cryptography. So what do these all have in common? They're all port operations. They're all I/O. So the magic, the common thread is things that you actually await are I/O. So you remember way back when I was going through the steps of the thread pool example, and I said that the system makes a continuation, which is a bookmark, and then it listens for that magic signal. Okay, what is the magic signal? How the heck does this work? You know, so the magic signal is provided by an operating system level function that in Windows is called IOCP, IO completion port. This is a low-level Windows function, right? You access it only through the Windows API. What this means is that the C# runtime is doing the pinvoke, right, API work for you, and it basically works like, hey, Windows, I'm going to make a port request. I'm going to subscribe to this other port. You signal me when my first request is done. I'm subscribing to the completion port. And then Windows will say, hey, man, ding, your thing's ready. C# picks that up, clears the continuation, gives you a thread pool thread, and off you go. So it's crazy to me that this whole framework is built upon this very low-level Windows operating system function. It's implemented, has different names on Linux and iOS, but they all support this concept. So in summary, async await doesn't do what I thought it did initially. Are you surprised? Maybe. Anybody here surprised? A little bit? Yeah. It uses IOCP and continuations to free up thread pool threads when doing lots of IO-bound work. And this allows a high-performance app to service many clients. You can still run tasks in parallel, but you have to use wait all, a task.waitAll. One of these bullet point work, these last two ones are the implications that I edited out. So I'm summarizing something that I didn't talk about. The sync async boundary and handling CPU bound work. So if those sound really fascinating to you, you can follow up by connecting with me on LinkedIn, going to my YouTube channel. There's a long form version of this talk plus 60, 70 educational tutorials on all kinds of things, Azure Service Bus, test first development, and I'm wearing different really cool shirts in all of them. So if all you want to do is appreciate my really fun shirt collection, you can do that. So honestly, that would be great. I'd love to get a few more followers and subscribers, and if you do all those likey, subscribey things, that's awesome. And if you do feel the need to communicate via email, I occasionally check csharpartisan@gmail.com. All right, so there you go. Async await explained. We have just a couple minutes if there's a comment or a question. Or just shock and awe. Yes, sir. You had a question?
No, just shock and awe.
Shock and awe. Okay, thank you. Right on. You guys have been great. I hope you have a wonderful conference.
Once again, don't forget to fill out the feedback form for the talk, please.
Hey, man.
Sweet. Thank you. Yeah. Well, I'm excited to be here. This is a much bigger conference than I thought it was. It's a ton of people, so very exciting. Like he said, I'm Boston Cartwright, and today I want to talk about the AI layer. So kind of to get started, show of hands, who here are front-end developers, including full stack? Majority, and what about back-end? Yeah, also majority, so mostly full stack, which is awesome. So let's talk about the new layer. So a little bit about me. I am here from St. George, Utah. If you talked to me earlier, I probably said Vegas because Vegas is a lot closer to St. George than Salt Lake. St. George is very different than Salt Lake, so I'm from there. I've been in the industry for maybe like 6 years. At work, I'm known for using a very large cursor. They all make fun of me for it. I never lose it. So if we look at since just from December to today, I submitted this talk last December. Agents meant a different thing than they do today. Vibe coding didn't exist. A ton of things have happened. We've got Claude 4 now, we've got GPT-5, we got 1,000 new models. Things are getting released every week. I think in the last 2 hours, GitHub decided to release their own CLI coding agent tool, also coined Copilot, but so things are changing so rapidly in this space, and I'm sure you've heard of that today. So what's really happening? Last month in August, I had the opportunity to attend a conference in Vegas called AI4. They kind of market themselves as the world's premier AI conference for business community. It was a big conference. It was like 8,000 attendees. I attended a bunch of sessions, and in each one of them, they defined agent differently. Some of them said it was a chatbot or something that makes actions or uses tools. Like, I don't know what an agent is these days anymore. They defined it way different ways. Vibe coding has also diluted. We saw that term only get introduced in February, and now it's kind of taken the buzzword. It originally meant you don't care about the code, you're just building a product, and now all the engineering leadership is like, we need to vibe code all the time, but we need to care about the code. And so like, there's a ton of things that are just changing fast. I kind of like to call what my vibe coding is AI-powered engineering, where you're able to use AI to help you. But I'm sure we'll see another name for it, I don't know, tomorrow. Someone will announce it here maybe. So we also saw Cursor is the fastest growing SaaS of all time. I think they were the fastest to hit 100 million earlier this year, and I think they're over 300 million annual recurring revenue now. So they're like crazy fast. Also Austin Allred, if you don't know Austin, he's been an educator in the tech space for a long time. He now runs a boot camp up in Austin, Texas, called Gauntlet AI, where they do a lot of AI learning. And he said that when he ran a survey with them, the consensus of staying on the cutting edge of AI requires at least an hour per day. So things are moving fast. The model race continues. But really, products are coming, and they're the important part. So I kind of want to talk about how AI is not a chat box. And I say chat box instead of chatbot because I attended AI4 last month, like I said, and this really influential person, I don't remember their name, but they gave one of the keynotes, and she kept saying chat box instead of chatbot. So I thought I'd continue, maybe it's helpful. But really, we need to not ship the lowest leverage pattern first. It's so easy to just get in there and make a chatbot where the LLM does the majority of the work, and then you just kind of get some of those rewards, but it doesn't help that much. I can't tell you the number of times I go to some website, and it tries to put up this little chat window, and it's like, talk to our guy about your question. I'm like, I really don't want to. I'd rather click 12 pages before I talk to them. So we got to get beyond the chatbot, right? It's not the product. Treating AI as a widget that you put on top of your product is not as powerful as actually embedding the leverage AI gives you into your product. So I want to talk about some of those patterns, and we've seen some of these. Some of these you probably didn't even know was AI. But let's talk about some of these and we'll go into how they work. First one is inline assist, right? So how can we help people to edit their content faster? Copilot kind of kicked this off with introducing inline assist. So you just start typing, the model suggests you can accept it or you can ignore it. We see this with cursor tab, I think they call it, or next edit prediction. This one's huge. People love it, I love it, I use it all the time. And it's getting even more powerful. Next edit assist, we're seeing, at least in programming, where it can go across files and things. But even now, I get surprised when I start typing a response to an email in Gmail, it tries to predict what I'm going to say too, which is super cool. Another one is decision support. So the capability that LLMs provide so that we can summarize and rank and highlight anomalies. So a good example of this is, let's see here, where we can have these videos are not playing automatically. There we go. Where we can have all this data come in and then flag things that seem like anomalies. So in this, we have a bunch of invoices come, and if it's above a certain amount, then we are concerned and we could say, uh-oh, let's take a look at this, right? So here we're helping the user to make a decision by highlighting the parts that matter, removing the noise and showing the signal. Another one is extraction and automation. This one's actually starting to take a lot more shape in the last few weeks, kind of getting coined like intelligent document processing, and just kind of like being able to take a lot of data and normalize it using LLMs. So this is like, okay, I have a PDF, I have an email, I can take all that and form this table of data, and then the AI can actually get a lot of that would be tedious process for us for data entry, but then it can flag things that maybe it couldn't find. Maybe the handwriting was a little messy or something like, it can flag those for us to look at later on. And then last one, this one's existed a long time now, is personalization. So specifically being able to do dynamic ranking and then adapting your UI based on that ranking. We've seen this in YouTube, Netflix, TikTok, Instagram, all of these where you have this set of items and then they can re-rank based on your actual user preferences. So we give them all a score and then they can re-rank and give you ones that you're more likely to click on, right? So these are some patterns. They're not all of them, but I kind of wanted to go through them to get your brain thinking on how do I use AI in a non-chat way? How can I actually get in there? Before I actually dive deep into the how. So this is kind of like the features that you can do, how to use AI, but now how do we build these features and kind of get into the technical part here. So first, what we really want to highlight, and I think I've said this multiple times, but I'll say it again, is we really want to highlight what's going to give the user the most value. So you want to take what is their biggest friction, how often do they do it, and do you have the data in order to improve it? And then if you have all that, then it ranks really high there, then that's what you should start hitting on. So I know I said defining the AI layer. I actually would say that AI is not a layer. I think it needs to be embedded in all the layers. Kind of like auth or logging or anything else like that, observability. I think AI is able to be enhanced there. I kind of like to think of AI as a spine on a book. You can read a book with all the pages without a spine, but sure is a pain. Then you stick AI on there and it helps a lot. So it enhances it, makes it way easier. Now the anti-pattern is, oh, we can do this cool thing with AI, let's make it that feature without actually seeing what the true product and value you're bringing. So I want to dive deep, and we'll have to go fast through these, but into 4 separate techniques. Domain-specific knowledge, so this is being able to give your LLM and your AI an expert in what you work in. So how do you make it actually useful in what you work in? Agents, I will give a definition of agents, that is mine, but we'll see how long it sticks. Tools and then evaluations. So first, for domain-specific knowledge, there's a lot of different ways. I know you've heard of a few of these. Let's go through them. So starting with continuous pre-training, this is one that you probably will rarely ever use. In fact, I'll be shocked if we have many people that have used this. This is the idea that you take a base model that's there, you add in some of your domain data, and this can be unstructured. It can just be a random thing of documents or anything like that. And then you retrain your model on a continuous loop every so often. So you take that, you train it, you of course evaluate it, make sure it's still correct, and then you get a new model, and then you do it again. So a good example of this is like family law, where it's changing often, and you know, there's new court decisions, tons of documents out there. It's not structured, it's not labeled. You can just continuously pre-train to get those results into your model, and then it's going to be smarter and make sure that your percentage is higher. Fine-tuning. This one I think we've heard about a bit, and maybe you guys have done it. This is where you take that same base model, but instead of just giving it a bunch of unstructured data, you give it structured data. This could be a question and answer or labeled somehow to say like, hey, with this input, you should give this output, right? And it basically doesn't give it new knowledge, but it kind of courses it to the right path that you want it to be on. So it's kind of like a coach refining a technique to a player in a sport, like a golf coach, right? They know how to hit the ball, but the coach is going to help them do it better. So the process here is you take your model, you format your data set, you do that training, and then you evaluate to see how much better it is. A good example is support reply. So we all have support bots and stuff in our companies. So you take these highly resolved tickets, high quality resolved tickets, you say, hey, someone responded really well to this. Let's take that into a data set that is structured, and then we can train our model or fine tune our model on that, and then it will score better because it knows how we want to answer in our specific space. Another one is prompt engineering. We've all seen this one. They talked about it earlier, in fact. You just want to ensure your prompt is optimized for the model. I'll say that I have found that models act differently to their prompts. Here's an example. I don't want to dive too deep in this one. It's pretty basic. As you improve your prompts, you'll get better results for sure, but there is diminishing returns there. Vector embeddings, or RAG, this idea that you can get data as your AI is running is really cool. So you take all this data, you clean it, you chunk it, and you embed it into a vector database. And then when a user goes to do it, what happens is you get the user query on whatever they're trying to do, you embed that query, and then you compare that to the database you have in order to get the data back, and then you unembed it back out and give that to the LLM to use as citations in your answer. So you can change a bunch of things here, but a good example of this is internal policy answers. So let's say you have a giant handbook and a bunch of notes, and you want to take that and be able to use it as citations in your app. We've seen tons of apps do this. GPT Search can do it now, Perplexity does it, and then you can do it for small things. I kind of want to show a demo here. Let's see if I can pull it up. And so I built one of these for my company a while back, so hopefully there's no secret stuff in here. But we have a Slack bot where I built that is trained on all of our security information, and our security team will go in there and ask it questions to get answers to fill out security questionnaires faster. So at my company, we get a bunch of security questionnaires from companies to make sure they're allowed to use our product and blah, blah, blah. And so they'll come in here and they'll ask like, hey, what is our policy on this? Or how do we want to answer this? And of course, the Wi-Fi doesn't work here. But they get answers. What's funny is we have another channel called Security Question. And that one's a public channel. Anyone in the company can go and ask a question to the security engineers. And I have found now that I provided this, and I provided this maybe in February, what they typically will do is take the question and come over here and copy paste it, and then copy paste the response and take it back. And I'm like, well, we should just put it in there. And they're like, well, we don't know if the answer is right yet. Like, they're struggling to trust it fully. So that's something I need to work on. But it's really cool to see them using it full time. All right, another one, agents. We're going to talk a little bit more about agents in a minute. But the idea that you can do things in a loop and even have tool use. This is really good for when you have more complex flows that's not deterministic, where you need to solve things such as a billing proration answer. So if we upgrade mid-cycle, what is the total? And then an agent could plan, how do I actually get this data? It could use a tool. I need to get the invoices. I need to get the line items, what the remaining days are, and then calculate it. This part is huge here, where you want to use a tool for calculations. LLMs are notoriously bad at math, but if you give them a calculator, they can do it. So, and then you can get the result there. So this table is kind of cool. It takes all of these items and kind of helps you understand when you want to use what. You kind of start left and go right. Continuous pre-train, which we talked at the first in this, is probably the one you would rarely use. But you can have a ton of data, and you don't have to have it labeled or structured in any way, right? Thing is, cost is also a lot higher with that. And so I thought this was a cool table that I made that kind of shows the different trade-offs that you get with these. So agents. To me, an agent is just an LLM that is in a loop. And that's the beyond, like that's as far as agents go. I will say, however, though, that business stakeholders will say anything that uses AI is an agent. It doesn't have, might not even use AI, but looks like it's using AI, it's an agent. So just keep that in mind as you talk to business stakeholders. The core pattern here is you just have a loop and you just call the agent again and again until it says that it's done. It's really that simple. When you would do it, I kind of talked a little bit earlier, is you want to use it when the task needs multiple steps, or it's complex, or there's chance for errors and you want to be able to handle those errors, or you want to change where you're going based on some results mid-run. And I added this note here that any AI usage is labeled as agent anyway, so just keep that in mind. And then tools. So LLMs know patterns. That's how they work. You talk to them and they give you a pattern. But tools let them touch reality. So you can go from deterministic to using fresh data, run code, or even take action. So I'm sure we're all familiar with a bunch of tools that we've used, especially in our IDEs and things where it can edit files or query databases or send emails or things like that. There's also MCP servers we're all familiar with. My hot take is I actually don't love MCP servers except specific reasons, but if you're curious about that, you can talk to me later about it. But and then evaluations. So evaluations are critical in this domain because it helps you to understand what's working and what's not working for your LLM, right? So you want to take away the glow of the demo and say, is it actually helping my customers? Is this actually bringing value to what they're trying to do in my platform? So Anthropic keeps saying, others as well, robust evaluations are hard to build, but foundational to responsible scaling. So the whole idea here is being able to use your product to know that you're making actual change to them, and you're providing guardrails, and you're not just hoping that the AI is doing the right thing. I think that's the toughest part as people are building AI tools is there's kind of, it's really non-deterministic, right? So you're kind of hoping, okay, I put it out there, is it actually going to do what I want it to? Is it gonna respond the right way? Is someone gonna come in and just jailbreak it and talk about trying to find a cure of cancer on my car application site or whatever? Like, it's really unknown, and so with evaluations and observability, you can get there. So evaluations are pretty, like, this is more complex than it needs to be, but a typical loop is hey, I have these data, these patterns that I typically go through. I'll run the models or my product through it. I'll score what the outputs are, analyze it, and see what's working, what's not working. We see this with benchmarks every time a new model is out. And then we're also starting to see this with benchmarks of products built on top of the models. I think the really popular one is Live Code Bench, is a really popular one that the models don't actually work on, but like the products on top of them. So Claude Code or Codex or even Cursor is working, having scores against that Live Code Bench, or Terminal Bench, I think, is another one as well. So kind of to recap here, AI is the spine. It really can give you a ton of leverage when you actually build it into your products themselves rather than just building a chat app on top of your product. You want to infuse it in the flows. It should feel like magic. Like your customers shouldn't even know that it's AI. It should just be like, wow, how did it know to do that already? I think Apple's kind of like the pro at just making it feel like magic. They had a lot of AI before they even announced their Apple Intelligence. And so just make it in there and avoid the chatbot. I'm just tired of chatbots. You can tell this is just a rant, not an actual informational talk. And then as far as you're trying to take your skills to bring it into domain, you want to start with prompt, go to those tools, fine tune. You might continuously pre-train, but only when it really makes sense. So what's your next move? My challenge here is kind of go in your app or whatever you're building and try to find 5 user frictions in the next week and then rank them. Look at them and say, well, do they do this often? Do they do this once and forget about it? And what data do you have about it, and how big is that friction? Is it adding hours or is it adding seconds to what they're trying to do? And then stand up an evaluation to start evaluating how long that friction is taking. So then you can add in AI-powered features on top of it, enhance it with AI, and then you can see the evaluation go down. And if you measure that, then you go to your boss and say, I improved this by 40% or whatever, and then you get 5 raises in the next year or something, hopefully, right? So anyway, I'm happy to answer any question. I think we have 2 minutes, or we can talk outside, but thank you.
Elder is going to be our next speaker today.
Woo!
He's going to be going over JavaScript, accessibility to be exact with JavaScript.
Righty.
Up to him. And also, for you sitting on the right, you'll get a better view of the slides. You go on that side.
FYI.
Either way, over there.
It's all good. It's all good. Alrighty. Howdy! Howdy, everybody! Woo! Hell yeah! Aw. I knew it! I knew you were gonna do that! Oh man, I am so happy to be here. All I gotta say is good afternoon, good morning, good evening, good everything. Happy birthday, happy anniversary, happy whatever you're celebrating. I am just so glad everybody's here in the moment, whether you're here in person, online. I really appreciate you, your time, your effort, and trust me, we're gonna make this a great presentation. I'm really hoping that you guys get into the motto that I'm gonna be showcasing and the appeal of the importance of this topic that is towards me. So one of the things that I wanna begin is giving this quote from an amazing philosopher from the 18th century, Immanuel Kant. And what he says is two things. Oh, really? Yeah. You're good. All right. Anyways, so the quote says, just to read out loud for y'all, two things fill the mind with ever new and increasing admiration and awe. The more often and more steadily we reflect upon them. The starry heavens above us and the moral law within me. So, given this quote, what I want to talk to you guys about is more of the ethical appeal of why accessibility is so important, why it's such a topic that is very relevant to when it comes to technology, when it comes to the journey that you guys are doing, whether you're starting the journey into dev, whether you're currently working towards it, or you're already in a job. It is very important to really think about why we're doing it. And so one of the things that I want to make sure that it's a takeaway from this talk is be an ally first. So accessibility, we tend to pretty much give it the acronym A11Y, mainly because accessibility has 11 letters in between A and Y, but also because it spells out ally. So the main appeal that I want to make for y'all is be an ally first when it comes to creating, developing applications or creating solutions to the world. And so the agenda for today is mainly to give you a compelling case as to why we need accessibility. Where can we begin? Some tools that will help you. What role can you assume? And most importantly, to humor my friend Brandon Hamilton, right there. Right there. I just want to make sure that he has a great time. So, without further ado, let's talk about why accessibility. Why do we are even concerned about it? So we're going to talk more into the ethical side of it, the pathological side of it, and the logical side. So we're gonna make the arguments of accessibility is the right thing, it's the smart thing, and it's the law. So what I mean by the right thing or the ethical case is that we want equal access to information for everybody. So the internet is no longer a luxury. Maybe about 30 years ago, it definitely was very scarce and ever evolving. But nowadays, it is used for everything. It's used to apply for jobs. It's used to connect with people. It's used to look into healthcare, be able to do your day-to-day task. It connects us. And so depriving that, it's such a horrible thing to do. And morally speaking, and that moral law that I see in Kant's words, we want to make sure that we provide that when working with technology, when we're providing the solutions that we want for people. We want to have and give respect and dignity to human kindness, to humanity, as well as spread diversity. Because one of the things that we want to take away from Kant is people are not
tools or people are not ends to they meet to an end. We don't think in a Machiavellian way. We think more in a progressive way, in a way that we have a duty to protect ourselves, to pretty much respect each other. And so when you create accessible applications, you're able to essentially create that bridge, that way to show respect towards people, show that you care about the needs and the ways that they can access your product. There is the social responsibility from both the developers and the businesses. So there's what we call corporate social responsibility, or CSR. You may hear that every now and then, but essentially there is a moral duty or a civic duty for businesses to ensure that we get things done the right way. So before I show that statistics, does anyone know, or does anyone want to guess how many people in the US alone has a type of disability? And it can be pretty much a permanent disability or a partial. So I saw one hand over there.
Over 61 million Americans.
Yes, sir. You got it right there. Totally because you didn't see. No. Couldn't be because of that. Nah. But good eye. That's all I gotta say. But yes, over 61 million Americans are diagnosed with some type of disability. That is 1 in 4 adults. That's 25% of the US population, or 25% of potential audience in the US alone. And this is not including people who have partial disabilities or temporary disabilities, such as a hurt arm or pretty much an eye having issues, what have you. So it's kind of like diminishing that number, but it's very important to recognize that those people exist. That's 25% of potential audience that you might be losing. So that's where we go into the business case or the pathological case. It is a way to create a market outreach, be able to reach to a untapped potential of customers, untapped potential audience that you really want to integrate into your product or whatever you're developing. It is also something that helps with what we call search optimization, search engine optimization, because at the end of the day, it's a bot that, for example, with Google, it just tries to capture as much information as possible. It tries to tell you, this is pretty much the content of this website or this application, and you want to optimize that the most you can. And with accessibility in mind, you're able to pretty much kind of cater into that, be able to design it in such a way that is like, yeah, makes sense to the robot, it makes sense, and it'll just make it look a lot better. And on the last point as well, it enhances the brand and reputation of any business. It just makes sense that when you're reaching out to that 25% of people, that additional 25% audience, you're able to create amazing experiences, amazing bonds with them, and they will respect you. They will definitely make sure that say, yeah, this brand, they care about me. I know, it's a bit optimistic, but but at the same time, it's one of those things that you have to keep in mind as an individual and as someone who represents a company or represents yourself, is that people will have that respect, that mutual respect, if you're able to pretty much cater that into it. And then finally, we have the legal case. In many companies, especially when they are funded by the government or the state, they are required to pretty much meet certain criteria to make websites or applications accessible. So this one, it's more of an ultimatum. So if you are pretty much someone who gets funded by the government or is about to, yeah, you should definitely consider accessibility. So in case that there's not that ethical appeal, well, guess what? We're going to sue you if you don't. But a couple examples of why that is the case is because we have what's called Section 508 from the Rehabilitation Act of 1973, which was pretty much kind of got an amendment not too long ago that allows to tell more about the guidelines on the digital creation or digital content. Same goes with the Americans with Disabilities Act that also states what's important, what things are required as a minimum. And for I threw an example with Texas as well. Texas also has the code 2054, which just allows people to say, yeah, if you're funded by Texas, you are required to do things for accessibility. So now that we established some of the cases as to why, where can we actually start? So the most important thing in accessibility, and this is pretty much kind of like assuming that y'all are either like starting into accessibility itself, or you're kind of familiar with it, but essentially there are 4 major criteria that you want to keep in mind. And I'm just going to keep them as a summary, just because there's so much content about it, but we'll go into that. We're going to try and identify what type of audiences you kind of want to target when it comes to working with accessibility, identify the type of work that you're going to do, and later on I'll talk a little bit more about your role, or the role of the people that are involved in it, because it's not just the developers. There's also involvement for designers, involvement for sales, involvement for leadership, et cetera, et cetera. So we'll talk briefly about that later. So the 4 core categories, or the 4 most important things to know about accessibility, is this right here. Being able to perceive, operate, understand, and have robust solutions. So when we have a perceivable product, what we mean is, can the users perceive, or they're able to interact with the content in such a way that it makes sense. Same goes with observable. Is it easy enough for someone who may have some sort of cognitive disability to navigate through your content and understand what's going on? The same argument goes with understandable and robust. That one is a little bit more tricky, but essentially means you got to make sure that technology is up to date, that whatever you're using, whether it be JavaScript, whether it be C#, what have you, that it follows all the standards that are up to date, because there might be things that deprecate, or new things that make it a lot easier, safer, et cetera, et cetera. That is still part of accessibility. So who is the most affected into this? So we have 4 different types of disabilities in general that we kind of recognize in web accessibility. So those are for vision, for auditory, physical, or cognitive disabilities. The most common ones are people with low vision, partial blindness, complete blindness, people who have partial deaf or complete deafness, people who are not able to operate things because they might be missing arms, or their arm doesn't operate in such a way that they can use a mouse, so it's pretty much keyboard navigation. Cognitive, this one's a little bit more tricky, but one good example would be people who are susceptible to epilepsy. So if your website has certain things that flash or trigger that type of deal, yeah, you want to make sure that you solve that as soon as possible. So some of the most common pitfalls into that, into accessibility when it comes to development, are just lower contrast text, or you're missing context about the image itself, links that make no sense, they might be empty, or they have very vague language, such as click here, read more, etc. Missing input labels, or validation, etc., etc. So now that we talked a little bit more about where to start identifying that, let's actually play with some tools. Now, as a caveat, most of those tools are like things that I'm just gonna demo for like a minute or so. We can go into that later on in a workshop, but for now, for this presentation, I would love to just make it as quickly as possible for y'all. So hopefully you can hear
toggle checkbox checked.
This voice. So this is what we call MBDA. And apologies to those who are in the live stream. You might not be able to hear the voice. But this essentially is a voice that allows users with no visibility, or users that have difficulties pretty much seeing what's going on, get a context into navigating into a website. So I'm going to use this beautifully designed website that just rocks, but
out of list main landmark heading level 1, out of highlighted heading level 1, out of
as you can hear, it pretty much tells you what's going on. And if I go into the tool itself, go into tools, and then this, I'll give you more context what's going on.
With
So
out of highlighted graphic heading level 1, visit this content info landmark. No next graphic.
So pretty much as I press buttons, it allows me to navigate and understand where are things. So for example, if I go Shift G,
Main landmark map graphic.
it goes to the previous graphic. If I go with L,
Content info landmark list with
it goes to the
items,
next
privacy
landmark or
policy, visit
link.
same page link.
If I press I,
Accessibility statement visited
Yeah.
same page link.
it goes to the next
Administrator,
visited
site
link,
map.
etc., etc. So this is pretty much how NVIDIA works. It's a free tool.
Exit. Exit Windows. Okay.
Yeah, goodbye. Goodbye. You were a great friend, but alas, I knew you. I knew the. But were you able to see that in? Oh man, dang it! I just realized, but. Yeah. Oh yeah. You totally. That's exact. That's aim. Yeah. Yeah. That. See, that was 4D chess right there. I wanted y'all to experience a voice first before looking at the beautiful website. So another tool that I'm gonna be showing y'all, if I find my mouse, it's gonna be right here. It is called Site Improve. So let me go into that. So if I click into this plugin, it's actually gonna tell me a couple of the existing issues of the website. As you can see, it's a perfect website. It totally has no issues. Don't worry about it. Don't worry about everything that says shows in here. The most important thing that I want to show with Site Improve, and as a caveat, while this tool gives you a general idea as to what the issues are, it doesn't cover everything, and it doesn't tell you automatically, oh, this is the way that you can fix it. It can give you suggestions. It can pinpoint you to the direction as to where that's happening, but it's not gonna be a solution for everything. But it's a helpful tool to just identify those things. One of the things that I love about this tool, and by the way, this is a free Chrome and Firefox extension, so just look for Site Improve, is the ability to change colorblind, the type of color blindness. So you're able to say, oh, so this is how they perceive it with the red-green blindness. Same goes with the blue-yellow, even though this one is a lot more rare. Yeah, it happens. That's how you're able to see the content. And as you may see in this screen, it's very difficult to already see the links. So imagine how it is when someone has this type of blindness. So this tool allows you to kind of have that visual, do more manual testing overall. And the other tool that I want to show, it is, and by the way, shout outs to my friend Mika, who should be somewhere around here, right there. Yeah, she works for DQ, and you should definitely reach out to her, mainly because she knows a lot better than me with this tool. But essentially, if you go into Chrome Dev Tools and download the Axe DevTool plugin, you're able to pretty much have the ability to do a full scan or do kind of like an AI scan. And by the way, this pretty much fills out the AI requirement for this talk. So you can punch your card on that. Because remember, after the 10th AI tool or AI thing that you talk about, Danny will give you free ice cream. No, I'm lying. It's actually 100. So just keep in mind. Don't quote me on that. Don't. But there you go. What I did was I did a full scan, and it tells me how many issues are there. It gives me a general suggestion as to what to do with the code base, how to approach it and fix it. So overall, not too bad. And I wish I could go more into that into this, but unfortunately, I only have like 6 minutes left. So we're going to speed run through as much of what we got left as possible. So let me do that. Should be back to tools. So already talked to you about these tools. So what should we do? Well, now that we know some of the tools, the arguments about it, what is my role? What is my responsibility? So when you're a front-end developer, you're literally the frontline defense to work on these items. You are pretty much the spearhead to the idea of making things accessible, being able to say, we have to do this because it's the right thing. It is a smart thing. And can be the law, depending on how you work with your place. And one common misconception is that backend developers don't have to do anything at all with with accessibility, but actually they have some ways to pretty much help, and that is pretty much creating a good foundation of their API, because people do certain APIs are exposed to the public, so they have to be consumed in some way, and they have to make sure that that information is both valid and easy to understand. Same goes with them being advocates for it, just because it's not like their direct role or their direct responsibility. They still have to do some work into that. Same goes with designers. One of the things that is kind of like a misconception too is just because I need to make this accessible means that I have to sacrifice aesthetics, which is kind of an incorrect way to approach it. It's more of having to have a holistic approach, a holistic view as to how to pretty much make that balance. And then with the leadership, it's all about creating that environment that accepts and embraces accessibility as a very core to the engineering team, and something that they should be pretty much encouraging and not think of it as a second thought, or just leave it behind. It's a very important thing to always keep in mind. So I have a couple of misconceptions. I'm just going to go real quick on them. So they say that accessibility is hard. It's not really that hard to implement, and especially with the tools that I show you. They give you really good suggestions. They give you an idea as to how to approach it, how to fix them. There are guidelines that help you everywhere. There are communities that allow you to get more of an understanding. Accessibility is ugly. It makes websites very ugly. Well, again, with the holistic approach, you have to pretty much know that you don't have to sacrifice aesthetics just to make things accessible. On the contrary, it actually challenges that and makes you really good at pretty much finding the right balance, the right in between. Accessibility is for a small audience, not really, because again, the statistics. And by the way, worldwide, according to the WHO, it's 1 billion people who have some sort of disability. That's 1 in 8. So 16% of global audience. So that's not a small audience to me, if you ask me. And then the most common one is, it's not my problem. Well, with the arguments that I brought earlier, and with the idea of that moral law within ourselves, within our duty to humanity, it definitely isn't. And also because there's more cases into it, and the biggest one, of course, is, well, it could be the law. So you want to get sued? You go for it. No, but anyways, who am I really to talk about it? So everybody calls me Elder, and I'm pretty much a tech lead at Innovation Associates. I am pretty much experienced with more than 10 years on accessibility auditing and fixing. I've worked with universities, Google, and CVS to pretty much get their material pretty much up to standards with WCAG. I have over 200 websites that I've worked on in the past, and overall I'm just kind of a menace. So I mean that last point is just just a warning more than anything. But with that being said, I just wanted to give you all some resources. So after this talk, we should have the slides available to the public, so you all can look at the notes that I've taken, the resources that are available. So no need for anything else. It also has some resources. A really good website that I recommend here is DQ University. Again, shout out to Mika. Look after her to get more info. This GitHub repository also has inaccessible websites that you can use to test your skills and abilities into it. And finally, I really appreciate you. I really don't have any socials, so I'm just gonna shout out to my girlfriend, Xiaoming Dai. I'm gonna shout out my boy, Brandon, who I'm really hoping that I gave him a really good time. My friend Belle, right here, Josh, David, Jay, everybody who attended. I really appreciate every single one of you, because I'm really pleased with that. Also, shout outs to my home country of Sweden. Thank you. That's it. Have a good one.
Speaking after Elder there, that was, I don't know if I'm going to be as good as him, but we'll see where it goes. Hi, again, JJ. I'm a developer advocate. Don't know what that means anymore either. But I really do have the email address of awesome@ibm.com, so you're more than welcome to find me there. If you don't know anything about IBM, getting useful email addresses from there is an act of Congress. And if you're lucky, maybe I'll tell you the whole story. So who's this first AI talk of the day? Anyone? Really? Oh, okay. I've been sitting in this room all day today, and they've had some interesting conversations around AI as a whole, but I'm going to take it a different angle. And I'm going to talk about what an open source AI is. I'm going to go through these slides really, really fast. And at the very end, I have a little choose your own adventure novel. And I want to show you what I can do with open source AI on my laptop for free in front of you live. And hopefully we can see the art of the possible together. I'm not going to show you something production grade by any standard, but hopefully it'll be enough of a trigger for you to be like, holy shit, this might actually work. So let's have some fun together. But first, I got to convince my boss that, you know, when he pays for me to go travel places, that people are actually watching my talk. So if you wouldn't mind giving me a little, take a picture of this QR code. It just sends you to ibm.com/granite. It hits a bit.ly link, in essence, where I can say that, yes, I had some people actually watching my talk. I have a couple QR codes throughout this whole deck. I also have a QR code at the end, so you can do it too. I'm a nerd, so I used Reveal.js to write all this stuff. Okay, so let's talk about like what actually an open source model is, right? Because that's one of the biggest problems. We all know our competitors, being that I am being recorded and live streamed, I can't be as honest as I normally am because I don't want this to be, you know, come back to me because of, you know, reasons. But we all know that there are some AI models companies out there, or AI companies out there based out of like Redmond, Washington, or maybe the Silicon Valley, that have a very different idea of how AI should work compared to a company like IBM who believes in the open source way. But what is an open source model? The largest problem is that AI models are binaries. So if you've actually ever pulled an AI model down from like Hugging Face or whatever, you'll quickly discover that there's no real source code to it. Like in the concept of pulling source code down from GitHub and then compiling it is not really possible in the AI space, right? Because all those safe tensors and all those actual files are binaries. So yes, you can still get data sets and you can still do the training with certain models out there, but you also need so much compute power, you can't do that at home. So the concept of being an open source model isn't just the weights. It isn't just, there's so much more to it that it's so far away from the layman. So the industry has actually come together and started thinking about this. Does everyone know what the CNCF is? Yeah, who does not know what the CNCF is? Do you know what the Linux Foundation is? Who does not know what the Linux Foundation is? Okay, so the CNCF is the Cloud Native Computing Foundation, which is the one that runs all the Kubernetes stuff, right? Is a sub-organization of the LF, which is the Linux Foundation. And inside the LF, there's something called the LFAI, which is basically the CNCF for AI. And that's where they've come together and created something called the Model Openness Framework, or the MOF, which gives us an opportunity so we can start talking about how models have the different openness levels of things. And that's actually really important because in order for us to all agree as an industry what an open model is, we need a standard that is not ran by a specific company. And that's why the LFAI is run with this. So if you have an opportunity, you're more than welcome to take a picture of that QR code. It sends to isitopen.ai. And if you are really serious about in this space, this is well worth your time to invest looking into. Obviously, Granite is part of this too. So the TLDR of all of this, and I really didn't go too deep into it because I want to get to the actual fun stuff. Nobody can really agree on what open source means, right? Like I touched on that with the data, the data, the model, the weights, and everything around it. There's no real open source concepts, and that's really causing a lot of problems. So the MOF seems like the only thing that really gives enough of a wide swath of a conversation that we can actually talk about this with. So
as we start spending into the time and the space, we need to start talking about a couple of the other open source projects out there. What's going on, Chris? How you doing, buddy? One of the ones out there is something called InstructLab, and this project is slowly but surely moving on, but I do want to actually touch on it because it is important because of something called fine-tuning. Fine-tuning is the ability to add new knowledge to models, and one of the problems with open source models is that data is stagnant, right? Like when you train it, a model only knows what it knows about. I know that sounds really weird when you say it out loud, but it's true. Other people have talked about this in this room where you only get up to a certain point. Well, fine-tuning gives you the ability to add new knowledge to models, which is really, really important. And what InstructLab is basically an opinionated workflow to leverage open source tooling to be able to do that training for you, which is really nice. They have something called a Q&A.yaml, which is basically a bunch of questions and answers, and you give it a really simple markdown document that has a bunch of information into it that actually be able to pull off of it. If I had more time and I wasn't going to show you the cool stuff, I'd actually show you this stuff right now, but you're more than welcome to click on these links later. So who does not know what a RAG is? Okay, cool. Just to make sure that we're all on the same page, in my mind, how I've described the difference between using something called, or fine-tuning and a RAG. If you imagine your AI as a librarian, a RAG is the library, right? It is where all this stuff is. It's really easy to add a new book to the library. Your librarian only knows so much, so if it doesn't know, it goes out to the library, finds the book for you, and brings it back. It can't regurgitate the information because they need it from the book. And then fine-tuning is the actual stuff inside of the brain, right? What does that mean? If you need to send new knowledge into something for the librarian, you have to send them back to school. That's a lot more expensive than just adding a book to the library. That's kind of how I imagine the space in my mind. Okay, we've all talked about agents and whatnot. I do want to talk about, this is moving very quickly. What is an agent? It is basically just a bash script now, or a Python script that we sit in the background that runs another LLM. That was supposed to be a joke, nobody laughed, cool. I do want to talk about the B framework out there. That is an LFAI project now, where if you are a Node developer, which I know a lot of you are in this room, you will love the B framework because you get the same aspect of crew AI, which is more or less the Python version of the de facto way of doing using the agent framework of crew AI, but you can do this with now Node, which people really like, and the B framework has obviously IBM behind it, which means it's not going anywhere anytime soon. And then AutoGen still exists for whatever reason. I just had to put that out there because of our friends in Redmond. So we all know if you start looking at Hugging Face, who does not know what Hugging Face is? Okay, cool. Well, in March 10th of 2025, there are 1.4 million different models out there on Hugging Face. And that's back in March. What month is it now? Right? Now, if you really think about that, that's a lot. And it's really hard to choose. And you have no idea what any of these models are, right? Because you can't really get the data sets, or you can't trust the data sets are real or anything like that. That really starts, you really start worrying about what happens with the models that you use, because you don't know if they've been poisoned, et cetera, et cetera. So that brings us back to Granite, right? Where Granite is the open source model from IBM that the TLDR of this whole story is that if you use the Granite model that we say is the Granite model, if you get stuck with any problems with attribution or copyright law or anything like that, IBM will go to court with you to defend this model. What is IBM famous for? Yes, our lawyers. I know we are. I'm not going to pull any punches. That means we are willing to put our business on the line if you put your business on the line to use Granite to use the thing. Admittedly, it's not as great as our competitors out there, but we're also building iTunes. Compared to our competitors, if you think about it, is building Napster, right? The ones that are out in Silicon Valley that all of a sudden started torrenting every single book ever written to train their models, they did not attribute those correctly inside those models. Those are stealing the human knowledge to train that. They did not pay those writers. They did not pay to deal with the copyright law. IBM, on the other hand, everything we've trained inside of our models, we've attributed correctly and did everything through public domain. So if you want to think about copyright law and the way we're moving towards, Granite is the way to go. There's a bunch of different models inside of Granite also, so it's a Granite family. There's Granite 3.3, soon to be 4.0. I wasn't supposed to say that out loud, but I did anyway. There's Granite Vision, Granite Guardian. Granite Vision basically is able to read charts, which is really nice. Granite Guardian puts some guardrails on things. Granite Embedding is our embedding model. Granite Time Series is actually our most popular model out there right now, which is the demo I'm going to show here in a little bit. And then Granite Code is basically our version of Copilot out there, which is kind of nice. Oh, the best part about Granite Code too is that we will absolutely go to court and give the data sets that we have trained on about what the code we did to do Granite Code. So we will make sure that all our licenses and all our stuff is enterprise grade. So if you're worried about the GPL, AGPL, or any of that code inside that gets created via these models, we can say with absolute definity that no, all of our stuff is Apache 2, MIT, et cetera, which is really, really important when you start looking in the enterprise space. So again, I've shot through a lot of this because I really wanted to talk about the use cases of what you can do with these types of toolings, right? Because everybody's boss out there said we need to use AI, right? We need to use AI. Where can we slot it in? And as engineers, we're just kind of like, I don't fucking know. Like, let's just go do the thing. Well, I've actually got some really useful use cases that have at least made my life easier that can actually, you can hopefully grasp on these different spaces. And I only got 13 minutes left, so I'm gonna go shoot right through these things. First one is the AI abstract classifier. So I run a lot of conferences too. Chris over there knows this all too well. I'm an organizer for something called DevOps Days Austin. And I actually wrote a tool that scrapes our sessionize or pre-talks, which is our CFP system, and then looks for sales pitches to make sure that somebody doesn't get on stage and start talking about their product the whole time. Anyway, the idea is basically to give me an idea of what could be a sales pitch out there, right? Surprisingly well, for DevOps Days Austin, this was last in May, it got 8 out of the 12 talks we were looking for bubbled up to the top, which was really nice. Out of about, I think, 120 odd talks. So that saved me a significant amount of time. I obviously did not just completely blindly take these talks, but it allowed me to bubble them up, which was really sweet. The next one is whose doctor has the best bedside manner? Everybody loves their bedside manner for them doctors, right? Well, if you didn't know, it turns out medical students only get one class their whole career on bedside manners to actually ask the question. So I wrote a little system called Pete that actually leverages Granite in the back end, so medical students can try to start talking through just text right now, again, art of the possible, to a fake patient and be able to be like, hey, what's your problem? What's going on? So they can actually engage in that way. Instead of having to go into this one class, now they can have an actual feedback loop. And I've gotten some very positive feedbacks on this one. Another one, all the dads out there, that's my daughter in the background over there, very upset. But what I did is I went to a STEM night and I actually used Granite to write some quick stories and then basically created images of what the stories were. So all of a sudden, all these kids were coming up to me at the STEM night being like, hey, write me a story about football and about my favorite team. And I'm like, all right, cool. And then what was really interesting is the parents got really like happy because now all of a sudden, they don't have to write or tell the same story about the princess anymore, right? They got the AI to be able to create the stories so they can have a new story about the things that you really care about, which is fun. And then what I want to show off now, or assuming I got time here, is this time series one. So I'm a type 1 diabetic. I have an insulin pump, as you can see right here. And I've actually used the time series model to project my insulin usage over time. So I travel for my job, and I have to take a bunch of my pump supplies with me to make sure wherever I go. And that's basically another suitcase. Well, using the time series model, I can actually figure out, well, over time, how much insulin I'm using. Do I really need to take, with the data that it has, where the health I am right now, do I need to take 4 or 5 new sets? Do I only need to take 1? I'm going for 6 days. Do I need X, Y, and Z? Which is really nice. Also on top of that too, I'm showing my gray beard here, but who knows what Nagios is? Okay, there you go. I got a couple. I've actually used a time series model to project disk usage. I'm actually going to Nagios WorldConf next week to present this to them. So you get to see a little bit of a spoiler here, which is going to be really neat because now you can actually take the same code that I have and be able to start projecting usage for your machines out there, which is really nice too. So let me see, I got 9 minutes. Let's go ahead and play with this for a second. So, who does not know what a Jupyter Notebook is? Got a couple? Okay, cool. So if I said Jupyter Notebook, y'all are not going to be like, what are you talking about, JJ? All right, good. All right, so bear with me for 2 seconds here. So here is, here's 2 Jupyter Notebooks. I have these already out on GitHub, so you're more than welcome to take all this code. So here's my first one, which is projecting the insulin usage of my blood glucose over time. This is also my data from my insulin pump, so you're more than welcome to use it. I've open sourced the code and my actual data from it. I'm also on something called the Medtronic system, where we learned the hardest part was the way to get the actual CSV out of it. so that's important to recognize. But what I'm going to do is I'm just going to go ahead and run all these cells and just kind of talk about what happens while this happens. So as you can see, it runs pandas, and it starts installing a bunch of stuff. And most of this should be cached, so it shouldn't take too long. Come on, don't make a liar out of me. There we go. So it does, what's happening up here is it's installing pandas, installing this TFSM public notebooks system, doing some matplotlib stuff, and creating the actual the data frame from the thing. As you can see, hang on, bear with me. Jeez, come on, really? Come on, there we go. And then pulls in some data. As you can see here, here's my blood glucose over back from there. It's just making sure everything's valid to what we're expecting to. And then this is actually how much bolus that I would deliver during the day, so I can kind of see the amount of total insulin I'm putting into it. And then this is just me graphing it right now, just to make sure everything is expecting what we want, right? I mean, it's just simple notebook stuff, but this is where it gets interesting. So here is this pipeline. This is actually the bread and butter of all we're talking about right here. And also you notice right there, most important, device CPU. I'm doing this all locally on my machine, right? All of this, I just talked to the AI and everything locally. I didn't go to ChatGPT, I didn't go to Gemini, I didn't go to Copilot. This is all open source on my laptop. And I'm not even using the GPU. And what it does is right here, which I know is at the very bottom and it's kind of lame, but it's still the art of the possible. With all that data from my blood sugar monitor, which is on my arm, I exported it out, and it projected that as my insulin usage over time. It stopped on January, February, March, and it projected all the way out to now. And as you can see, it's less and less usage of insulin, which is actually a really good sign, because if you don't know, as a diabetic, you want to take less and less insulin over time because you have insulin resistance. And that's also showing along with me losing weight too, which is cool. So if anything, showing this to my doctor, I take less and less insulin. Everyone following me? Thumbs up? Yeah. I know this is a lot, but I'm trying to I've got only 6 minutes left. Okay, so now let's go to machines, right? So the same kind of principle with the Granite time series infrastructure monitoring here, which I will go ahead and just run all this stuff again. And I want to make sure, so as you saw, I deleted everything. It's all running this live as we speak. While this is going, I will go ahead and I want to make sure we have time. So while that's running in the background, hey, if you are actually interested in this, how do I actually play with this stuff? I'll take a picture of this guy right here. This is a QR code to our open source workshop, which will walk you through everything you need to do to get running on your actual laptop right now for free. Installing Olama, getting the correct models down on your machine, playing with some stuff, even including using RAGs with open web UI and a few other things. But if you want to actually do more of the nerdy developer stuff with like Jupyter Notebooks, The Granite workshop here is what you're looking for. It actually has a bunch of cookbooks. So if the term cookbook means anything to you, that's really important to know. You'll actually be able to see how you can slot in with some very simple Python the open source Granite models too. And just if you haven't actually, if you missed all my code or my stuff, please take a picture of that. This is a direct link to the presentation we just did. As I said, this is all out on my GitHub on Reveal.js. So by the time this is done, and again, we only got 4 minutes, I should be able to come over here now and click on this guy. And as you see, it does all the setup, and then make sure that everything is loaded correctly. And then as you see, I have a bunch of Nagios logs here that I've already open sourced and pulled directly from it, pulled some data from each and every single one of them. And then again, I'm using, again, the CPU, not GPU, doing the CPU, to pulling out some just generic information about it, and then graphing it out here. And as you can see, it projected all of these red lines to saying what it did. I don't actually know what happened here. I think I just wasn't running my Nagios box or something at the time to write. But as you see right about here, and this is actually accurate, on the machine, I did get a warning telling me that I would be officially running out of disk space on that machine. And then just for fun, here is a very useless graph, but it did actually project it. This is CPU load average over a minute because the machine doesn't do anything apart from Nagios, but it at least is a nice little sanity check to make sure that it is projecting something that is accurate, which is pretty much nothing. And I believe that's, and then, just output. That's more or less it. I'm so sorry we only have 3 more minutes. If you have any questions, I hope you feel like you learned something. Thank you. Any questions, thoughts? Feel like you learned something? Yes, please.
Did you go back and check if your predictions were correct?
Yes, and it turns out they were. I did this, all this data is up till March or April, and then it projected out till about June, and right now it is accurate, yes. I mean, there were also very simple projections, right? Like they're not crazy by any standard. Again, I want to show the art of the possible, but it did actually get the numbers right for what I was expecting. Yes, sir?
So the projections were looking like a trend line?
Yes.
Does that model also like do the seasonality in it?
So the great question. One of the interesting things from this experiment when we learned is that, as you said, it is just basically a trend line, which isn't that exciting. But if you add more variables to the model and give it more information, it actually gets better and better about what's happening because it knows about more variables to be able to work with. I didn't go too deep into that in this conversation, but if you drop me...
But you could then make that zigzag line out of, like, as a prediction?
Not exactly, not exactly. But you can get a better, more accurate trend line to give you more granularity on it. And if you drop me an email, I can send you some more information about it. But normally that is more advanced than I need to talk about in the talk to get you to get more, like I want to show you that the art of the possible before going into, okay, this is actually how you do it, if that makes sense.
Yeah, absolutely.
Yeah. So another question? No? All right, well, thank you again, y'all.
What are your minimum requirements for running models quickly?
This, I would say just basically an M2 processor.
How much RAM?
Well, on a Mac, I would go with at least the 16 if not 32.
Okay, that's entirely reasonable.
Yeah, it's extreme.
All right. Well, thank you all for coming. This is the session on automating secure. Oh, I did not turn on my mic. You can hear me? Yes. Oh, can you double check? Am I on now or? Okay. All right. Thanks. So this is the session on automating secure OIDC-based cross-cloud authentication. My name is Porco. Just a quick introduction about me. I'm a software engineer based out of Ottawa, Canada. I enjoy running. I often go on early morning runs along the Rideau Canal that's pictured here. I listen to a lot of podcasts. One of my favorite podcasts is Stuff You Should Know. I highly recommend it if you're interested in learning random trivia. And I used to study physics, so I'm very passionate about all things physics or science related. So the key takeaways from my talk are we should not be using access key IDs and secret access keys when accessing AWS in production or environments that require high degree of security. A better approach is to use OIDC for secure system-to-system authentication, and we should leverage automation at scale to improve security and reliability. So I'll begin with a quick review of the AWS IAM service. It provides centralized identity and access management. So it provides us capabilities for creation management of user identities. So I'm referring to things like users, groups, and roles within AWS. Permissions in AWS are granted through IAM policies that define what actions are allowed on specific resources. And IAM roles are used to assign these permissions to groups or users. Fine-grained access control helps us implement the principle of least privilege by ensuring users have permissions that are only needed for their specific role. IAM integrates with external identity providers, so things like Microsoft Entra ID or Okta to enable single sign-on. It supports both SAML and OIDC for federating access to AWS, and this reduces the need for separate AWS credentials and improves security with centralized user management. Finally, AWS IAM enables issuance of temporary security credentials through AWS Security Token Service, and temporary credentials are automatically revoked after a set time, reducing the risk of stale access permissions. So access keys are used for programmatic authentication to AWS, so I'm referring to things like the API or AWS CLI or SDKs. So there are two components for access keys. We have access key ID, which is public, and then we have a secret access key, which is private and must be kept secure. So you can think of these as a username and password pair, and they allow you to programmatically authenticate to AWS without the need for console credentials. So here I have an example of a AWS credentials file. So if you've used AWS CLI, we have configured this to enable access to your AWS account. And we have a dummy example of access key ID and a secret access key. So after reviewing that, we should not be using access keys when authenticating to AWS. These are long-term credentials that can be compromised if exposed or mishandled, leading to persistent security risks. They're against prescribed AWS security practices coming from AWS. Managing access keys across multiple users, services, and systems becomes complex and challenging as environments grow. Access keys are a lot harder to track and audit compared to IAM roles. In corporate environments, enterprise policies will dictate and prohibit use of access keys as well. And if your corporation or company does business in regulated environments, your business regulations will also dictate that you do not use access keys. Additionally, access keys are tied to specific IAM users, so that means that we cannot use RBAC to only assume roles needed for specific use case. So better approach is to utilize OIDC. So OpenID Connect is an authentication layer built on top of OAuth2, enabling identity verification using token. So these tokens have claims, which is information by the user, as well as scopes, which is information by the permissions that the user may have. So this allows us to implement fine-grained authorization in applications by controlling what data a user can access based on their identity. OIDC tokens are short-lived and can be dynamically scoped, reducing the risk of stale or overly broad permissions that are common with IAM access keys. It allows applications to authenticate users via external identity providers like Microsoft Entra ID. And OIDC is commonly used for single sign-on, allowing users to log in once and access multiple applications. It reduces the need for separate credentials in AWS IAM. So it provides us a more secure and scalable user authentication compared to long-term AWS IAM access keys, which are prone to exposure and management overhead. So AWS provides us OIDC functionality through its AWS IAM OIDC provider service, which allows external identity providers like Microsoft Entra ID to authenticate users to access AWS resources. It enables federated access, allowing users to sign in using their credentials in those external IDPs without needing separate AWS IAM user accounts. So it's useful scenarios where we want to grant access to external parties, for example, external contractors or third-party services, to access AWS resources without needing to provision IAM user credentials in our AWS account. It reduces the risk of credential leakage by using short-term tokens instead of long-term IAM access keys. And IAM web identity roles are used to grant permissions to external entities into our AWS environment. So Microsoft Entra ID is Azure-based identity provider. Formerly, it was known as Azure Active Directory, and it's a comprehensive cloud-based identity provider, providing us capabilities for the full management of lifecycle of users, such as provisioning and deprovisioning of users and management of their access permissions. It has a comprehensive suite of governance and security features, such as conditional access policies, multi-factor authentication, advanced reporting, and additionally, it provides federated access enabling SSO via SAML or OIDC. And it allows us to create application registrations within Entra ID and configure their OIDC. So we can take these two components and come up with a integrated solution to enable OIDC authentication into AWS environments. So we would start by registering an external application, for example, your CI/CD system inside Entra ID. That client application can then log into Entra ID, and upon successful login, it would obtain an Entra ID token. Then it can use that token, the Entra ID token, to contact AWS STS and exchange it for a AWS STS temporary token. And then finally, using that AWS STS token, the application can assume an IAM web identity role and gain permissions to perform actions inside the AWS environment. So this whole solution is enabled by a trust relationship that's developed between the AWS IAM OIDC provider and the app registration inside Entra ID. So there are three configuration steps needed to implement this. Number one, we need to create an application registration inside Entra ID. Number two, we need to add the audience value to the AWS IAM OIDC provider. And number three, we finally need to create an AWS IAM Web Identity role. So this is a screenshot of how we create an application registration in Entra ID. Once we create our application, we would be given an application or client ID that's given here. We would use that value as the audience value when configuring our AWS IAM OIDC provider. And then finally, we would create a IAM Web Identity role for our OIDC provider, specifying the audience for our application registration. And then this shows the trust policy that basically creates the trust relationship between the web identity role and the application registration inside our Entra ID. So there are several challenges with manual configuration in enterprise environments. Namely, it can result in violation of security policies and compliance policies, because when done by different individuals, it can result in varying approaches and setups. Also, this solution requires substantial access privileges in both AWS and Entra ID, both of which are very important services in your landscape. So this can potentially lead to significant security risks. Also, it requires deep understanding of both of these platforms, which can be, the competence for that can be difficult to find in people, considering they're both in different cloud providers and can require substantial additional training. And finally, manual configurations are always error-prone. Also, enterprise organizations use multiple AWS accounts for various purposes. So you will have things like logging accounts, networking accounts, security accounts. Various business units may have their own organization units and their own AWS accounts. You will have different environments such as dev, test, staging, prod, and these are often broken into many different multiple AWS accounts. And additionally, you may have temporary accounts for developers, sandbox environments, or proof of concept use cases. So many organizations use things like AWS Control Tower or AWS Landing Zone Accelerator or other automation pipelines to programmatically create AWS accounts at large scale. In these scenarios, this automation can create the AWS IAM OIDC provider in each account. However, there still needs to be additional automation in order to configure the OIDC properly. So this solution shows a comprehensive solution to implement automation for OIDC configuration. So on the left, we have just a sample account A, that's newly created account via our automation. On the right, we have a centralized account that can contain our OIDC configuration factory. So the whole process starts with the creation or deletion of a AWS IAM Web Identity role. That event is recorded in AWS CloudTrail. We can have then event bus event rule that filters and captures that event. And then the two accounts are connected via event buses. And then in our factory account, we'll also have an event bus rule that will filter the events that we want and capture them, and then trigger a Lambda function. This Lambda function is responsible for invoking one of two state function workflows. So the first workflow is, well, I'll just review quickly both of them. The first workflow is is concerned with the events related to the creation of IAM Web Identity roles. The second workflow is concerned with the events related to deletion of IAM Web Identity roles. So taking a closer look at the first workflow, it has 3 Lambda functions. The first Lambda function invokes Entra ID API to register a new application in Entra ID, and it returns an audience identifier for that application registration. The second Lambda function is responsible for taking that audience identifier and adding it to our IAM OIDC provider in account A. And then the final and third Lambda function is responsible for updating the trust relationship in the IAM Web Identity role to add that audience identifier. So this step is needed because unlike in the manual setup, when we create the web identity role, we don't have the audience value yet. So we just put a dummy value, but then this automation will update that value a few seconds later. And then the second workflow for the deletion of the web identity role only has 2 Lambda functions. The first Lambda function just invokes Entra ID API to delete the existing app registration. And then the second Lambda function removes the audience identifier from the IAM OIDC provider. Okay, so to summarize again, the key takeaways are: in production or high secure environments, do not use access key IDs and secret access keys. Instead, a better approach is to use OIDC to enable secure system-to-system authentication. And at scale, we should be leveraging automation to improve security and reliability. So I have a few minutes left, so we can go through a quick demo. Hopefully it all works. Okay, so here I have my Entra ID and my identity provider for my Entra ID. So I begin the whole process by creating, okay, this is a little awkward, by creating a role. And we're going to create a web identity role for my Entra ID, and we are selecting a dummy value, as I mentioned. Great. Okay.
It's just very secure.
Okay, and then we'll just grant it, let's see, view only access permissions here. So as you can see here, this is dummy value in the trust policy. Oh, I need to give it a name. Okay, so we've created the dummy role in our account A. I'm going to switch now to my centralized account. So if I go to step functions here, and I take a look at my creation step function, it ran. So there were 3 steps here. So that means there should be a app registration now created. There we go. And then if I go back to my account A, and if I go to IAM, and identity providers. There we have the client ID has been added, and then I check my role, and we should see that the trust policy has been updated as well. Okay, and then yeah, so all that code is on my GitHub. It contains the source code for implementing everything in the factory. So there's Terraform code for all of the resources, IAM policies. There is code for the step functions and the Lambda functions. This presentation is available on my GitHub as well, and there is additional info if you want to connect with me. Thank you very much. Right. Are we taking questions? Yeah.